Hello, my name is Rich Howard, owner of Architectural Builder Supply, and this video is to bring you a closer look at the Parker door bottom, the PDB, either the 411M or the 411S. Basically what we have here is an automatic door bottom, is what the PDB system is. This is a PDB411. Think of it as Parker door bottom 411. This is the M version because it's a mortised style. This will get mortised or installed into a mortise that you would do in the bottom of the door. There's also the PDB411S. It's a surface mount version. It's basically this entire housing that you see here without this flange. In fact, it's the same thickness as this, just without this bottom flange, and then it's been prepped to be surface mounted. So in this system, you're going to get a mortise style or a surface mount type. You're going to get the ability to order it in lots of different lengths, from really narrow to extremely long. You're going to get the ability in the surface mount to have an added-on cover that, in theory, can be done in any color that you need, black or dark bronze or white, or you're doing some sort of a project where you do have a custom color happening. The Parker door bottom can be ordered in that custom cover in a color that you would want. That can be accommodated. Several other reasons why this item is absolutely worthy of your consideration, and I will put it at the top of your list when it comes to automatic door bottoms, because it's a single unit, either in a mortised or a surface mount, and admittedly surface mount are more common. And again, later in this video you'll see where we take a surface mount, we thoroughly analyze it, we thoroughly disassemble it, we thoroughly go through all the internal parts, we thoroughly trim it down to a non-standard custom size, and we thoroughly install it, and then we give a review or a post-mortem of our installation as well. So, why would this be the one automatic door bottom that you should consider? Let's dive into that right now. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Now, the second part of this video is going to be the review of all of the points, the reasons that you would want to consider this automatic door bottom. After this second part, the third part is going to be a switch to the camera view so that we can look at all the supporting information. And then after that, we're going to take a surface mount, the surface mount, completely disassemble it, identify all the parts, study it, become at one with the hardware, understanding how it works by looking at all the parts. And there are not many parts to this unit at all, because at this moment I've already shot that part of the video. I'm already familiar with how it works. So why consider this? Well, first of all, a little bit of background. Parker door bottom is Brian Parker and his company. He is a gentleman who has decades of substantial industry certified experience and accreditation, in fact, in acoustics. He has the experience in the industry that allows him to understand problems and then design solutions for them. And he has come up with a product that's been in the market, just under a different sort of license, licensed to a major manufacturer and used in a particular setting under a different part number, although similar. He's devised an item that is truly a one solution for almost every condition that you have. And where you might say this is stop short of a solution, I will seek to be sure to have a response for any sort of shortcoming that you see in this product, because I have traveled to England, I have traveled to the southern part of England, I have gone to the factory and spent hours with Brian Parker and his team, and have had at that point become extremely familiar with exactly how it all works. I have an intimate understanding of the entire process because of that trip. So let's dive into it now. As I go through all of these points, this is a list of 24 reasons why you should consider this item compared against to what you're already using. First of all, their door bottoms are grade 1, which means that they've been tested to 1 million cycles. There was conversation when I was at the plant about, well, how many cycles would it go to? And the response was basically, we don't know. We stopped testing it after X million. So the bottom line is that tells me that you would likely never see one of these fatigue or fail through the course of standard usage. So it's grade 1, which is the highest grade that hardware is tested to. That means 1,000,000 cycles. Think about how many times that door might be cycled a day. Let's say that it is a hotel, and let's just say that that is 10 times a day. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, let's say 16 times a day. Okay, let's 1,000,000 divided by 16. That's 62,500. Let's divide that by 365. Yep, that's 171. Now we're talking years. Okay. Let's say that it had 100 cycles a day divided by 365. That's 27 years. Now, if that's not good enough for you, let me say this. Parker Door Bottom puts a 7-year warranty on this product. So you are not going to have a fatigue or failure. It is not unusual for an automatic door bottom to fail, to have a client call and say it's broken. Admittedly, though, in some of those instances, they've done something to break it, where they've intentionally pushed the unit extended over an obstacle. They've known that they're going to break it. But there are times when automatic door bottoms are just broken and they have to be replaced. Doing simple math, if grade 1's not good enough for you, and based on an average volume, take that 7-year warranty. That's got to be something worth consideration. That's actually 2 points. The third point would be simple design consisting of less than 10 parts. I'm going to count them in my head. 1, 2, 3, 4, 5, 6, 7. There's 7 internal. The plunger, I guess, would be 8. 8 internal parts. There's the aluminum housing, which could be 9. There's the drop bar, which could be 10. And then there's the rubber insert. Let's say that's 11. So extremely simple and elegant design. Very few parts. And when I disassemble it later in this video, you'll see, wow, that's really easy to understand. There's no voodoo and black magic happening with this automatic door bottom. In fact, you could order these and you could with complete confidence be able to resize these. Now, it's not something that you just cut and you're on your way, but with the Parker automatic door bottom, it's just cut it and you're on your way. They have an advantage that others simply don't, and I will get to that in a moment. So, elegant design, simple design, very few parts. And in fact, there's 3 moving parts. Well, there's 4 moving parts. The plunger, the 2 arms make 3, and then the drop bar itself. Only 4 moving parts. The Parker door bottom, very elegantly, and I'm referring to my notes if my eyes are off a little bit. The Parker door bottom elegantly solves the problems of a weather seal, an acoustical seal, and a security seal. All in one every single time that you order one. So a weather seal is obviously going to be the EPDM rubber that's coming down. Every single time that's going to make contact with the floor. There's your weather seal. Your acoustical seal is that right out of the box. This is STC46. If you use this with other known components, the entire opening can become an STC52. Now that's nothing to shake a stick at. STC52 is when you are going to need, when you're doing an STC door, you weather seal it on all 4 sides. The header, the sill, and the jambs, and usually using multiple components. Right out of the box, this is STC46. So why is that important? Well, you're not going to go through all the steps of bringing it up to north of STC50 because it's not an application that requires it. But your application absolutely demands reducing the transmission of acoustical energy through doors as much as you can. Post-COVID, right now it's the very end of 2022, we're still living in that, well, it's certainly post-COVID, but we're still living under that general fatigue of COVID. A lot of people working at home. Now, I've worked in the office, and I've worked at home, and I've done both for many, many years. I worked in a home environment for a decade. And it's great. It's a trick. You end up working more than when you end up going to the office, but working at home has its advantages. However, it has some situations that you need to learn to adapt to, and that is the rest of your family being there when you just need to work. And when you work at home and it's silent, you become very accustomed to that. When someone else is there, that becomes, I wouldn't say an irritant, but it becomes something, at least for me, that was a order of magnitude greater sort of obstacle, distraction. And people call all the time and say, I just need to turn down the sound of the television on the other side of the wall because I'm in here working. And the reason you want to look to solutions that are STC rated, like the PDB product, is because you don't want to go out and tell your family, turn the TV off. They have to live their lives, but you have to get work done. And once you get used to working at home alone and it's quiet, any sound can be a distraction. I know that that's how it became for me. I transitioned from work life, workspace, going to a place to work, to working from home, transitioning back to working in an environment where there are many other people. And there's adaptations both ways, but I can tell you adapting to a quiet environment and then having that intruded upon is difficult. So the Parker door bottom nails or goes a great distance to solving the acoustical issue. Third, it's also a security seal. Now, many door bottoms are not a security seal. This unit, when it comes down, it's got this feature right here of the door bottom, which is this aluminum component to it. As soon as these little fins make contact, so too is your aluminum bar. Now, what's interesting about this design is, and you'll see it later, there's a steel rod that goes through there, that goes through the entire unit, up in here, and I'm going to show it to you. When you push this in, the plunger in, that rod doesn't bend, it doesn't flex, it just moves. That rod is connected to the two arms. Those two arms are fixed together. They only move like this as a result of the plunger being moved in and out. Okay. What happens is the plunger gets pushed in, the rod connecting the two arms moves like this. Those two arms then are forced to deflect. That deflection is what pushes the the drop bar down and seals. The drop bar's got the two pieces of EPDM on either side. Easy, very easy to replace. You can buy replacements. That seals. Now, in a hotel environment, there are tools that people that run, manage, own hotels have that will allow them to bypass the lock very easily and without leaving any sort of trace that it's been done. It's a very simple tool. It's a very inexpensive tool to mimic, to copy, to create, and to use. But that tool requires, as its exploit, to get something under the door. Well, when you have a piece of aluminum that's making contact with the floor, and those two arms are deflected, and because of that steel rod connected to the plunger, which cannot move because it's making contact with the soffit of the frame, that bar is not going to go up. Sure enough, because of that, you are not going to stick under the door any sort of bypass tool. The bypass tool goes under the door, gets to the lever, pulls it down, the door opens, no one knows you did it. The Parker door bottom serves to defeat that to a great extent. Could you take a crowbar and get underneath there and destroy the hardware? Sure. Could you take a battering ram or your size 11 foot and kick the door open? Sure. Hardware is not meant to prevent forcible means of bypass. But it does act as a security element here. And you'll see the steel rod to the two arms connected to the plunger. All that linkage does is just move back and forth. My camera came out of focus. Move back and forth, deflects the arms, drop bar comes down, the EPDM makes contact, as does the aluminum with the floor. So you have, in effect, a weather seal. You have an acoustical seal. We're going to talk about that in a moment, why it's an acoustical seal. It's an acoustical seal because Parker Door Bottom Company has tested it. They've had an independent laboratory test the hardware. They can call it STC46 right out of the box because it's been tested and found that it hits that requirement. It's also a security seal because of that aluminum bottom. So what we're doing in this process, and we're only, by the way, at 4 of 23 reasons to consider this, is this deep dive, this forensic analysis, is meant to serve as to say to you as the potential client, there's a lot more to automatic door bottoms than one might realize. As you're shopping for one, your criteria are very likely how to install it. You know, is it conducive to how I will install it? Surface mount, probably. Color, probably second, and then price. There's a lot more to automatic door bottoms. And I will argue that this is so full-featured and very fairly priced, there is no reason to consider others. All right, let's move on. This is a great design because you can trim this down in the field far more than you can any other manufacturer's product line. You can trim any size that you order in terms of disassembly of all of that. So just to back up, because you may have missed some of that, any size greater than 24 inch, when it ships from the factory, 24 inch or longer, this might be 24 inch, it is. I have a 36 inch here, it doesn't matter, I'm just using the smaller one because it's easier to hold in my hands, show on the camera. This can be cut down 4 inch. In fact, I took a 36 inch, you'll see later in the video, I took a 37 inch really, and I cut it down to 29 5/8. So I cut, 8 inches off of it basically, or 7 inches off of it. I could have easily have cut that down to 14 inch if I wanted. I could have cut it down to probably 12 inch for sure. The point being is any size, 24 inch all the way up to their maximum length, and I know they've done 60 inch. Mr. Parker, or Brian, we'll call him, he doesn't see any reason why they couldn't make it 8 foot long. I don't either, based on my now intimate understanding of the internals of this. So why is the trimmability important? It's important because you'll call and say, oh my gosh, my door is 31 inch. What size did you order? 36. Can't cut it in the field. Or my size is 30. It needs to be 32 3/4. What size did you order? 36. Can't cut it in the field. That's awful. Customer doesn't want to cut it down in the field, doesn't want to try, doesn't want to learn how to do it, and I'm not saying they should. But for sure that automatic door bottom they have no use for. And if you are a homeowner and all you're looking to do is to reduce that acoustical transmission from the TV to your nice quiet workspace, that doesn't work. Now you've got a $60, $70, $80, $90, $120 piece of hardware that you have no use for. No, not with this. Not with this. You could literally, and I'll show you later, make one observation about, well, I'm sorry, this is the mortise version. You could make one observation about what I'm assuming is your surface mount. You can cut that right on down, opposite the plunger side, and there's nothing to worry about. You're not going to get close to the parts that keep it held all together. That's it. Now, if you needed to take something and cut it down more than 4 inch, you can. And later in this video, you're going to see me cutting one down 7 inch, which meant I had to thoroughly disassemble it. I had to reposition parts. I had to modify a part, and I had to re-drill and countersink a hole. But it was really no big deal. The point is now that I know how to do it, I could do it in 15 minutes. I could do it in less. So you're not going to get stuck with something that you'll have no need for. Okay. These can be manufactured for sure down to 12 inch. Brian believes that they can probably be made down to 10 inch. I don't personally know how he would do that other than modifying the flat springs that are in there, which I think would work. Doesn't really matter. I've never had someone ask me for a 10 inch in 32 years. 12 inch is nice because you could have a really small pair of 1.0 doors, a 2.0 opening, but I think the smallest we've really ever sold is 16 inch or maybe 18 inch, so you're never going to encounter that. So if you have a door that's narrower than 24 inch, you're going to need to order it that size. But if you have anything wider than 24 inch, you'll order it 24, 26, whatever you need to order it at. You know that you can take 4 inch off every single time. So all of the steps that you go through to modify its length, we're going to go through in detail later. Now, uniformity in the dropping and lifting cycle suitably for sliding doors, as well as reducing drag of the mechanism on the sill. So what that part means is when you press the plunger in, that forces this bottom to drop uniformly. A lot of customers get their automatic door bottoms and they call and say, this is broken. And I say, yeah, why is that? Because it doesn't drop uniformly. One end comes down and the other end doesn't come down at all. Well, we end up discovering why that's the case, and it's because they have an uneven floor, is the bottom line. The design that Brian has, the design defect possibly that Brian has exploited is, if you have a floor that's not level, and it sounds a bit extreme, but many floors are not level to the point where an automatic door bottom cannot be used as a solution, because when the door closes, the plunger is going to hit the soffit or the stop, but we call it the soffit of the. It's the stop, but it's the face of the. It's the soffit. Plunger hits that, starts to lower, but in these other models, that end drops first near the hinge, and then it knifes down. Well, the problem is, what if your floor pitches up towards the latch side, which means you drop and you don't make contact with the floor adequately because it's that out of level, and then it knifes down either not at all or an inadequate amount. The issue with that now is that you don't get a seal. This model, because as soon as the plunger starts to make contact with the soffit, it starts to drop. It just starts to drop, is the bottom line. Now, one advantage of that, of this system, is that you will have contact. As you go to open the door, according to Brian, this has a 2-to-1 lift ratio. So it takes very little opening movement of the door to get that bottom to start to snap back up. And in fact, later in this video, when I install the item on our office door up front, I can tell you it requires a small amount of opening the door to get that thing to come back up. The only contact that I can tell I have with the floor is when the bottom comes down. My two fins of EPDM, they're kind of moved over like this because they're making contact with the floor. You can see that they're kind of curved like this because they're making contact. Now, when I go to open the door, those two fins have to fold over and then back because now they're acting a little bit like a door sweep for a very small amount. And you know that you have contact when you open the door, and you can feel the fins go from this orientation to straight to folding back, and then by the time the door is basically breached the rabbet of the frame, you're snapped up enough, you're brought back up enough to where, well, in that very close to that degree of the opening cycle, you can tell that the bottom's coming back up to the point where now it's free of the floor. And the advantage of that 2-to-1 is the advantage of the 2-to-1 and the advantage of the uniform lifting of the bar is that what are automatic door bottoms really good at? They're good at sealing the bottom of the door, but they're good at sealing the bottom of the door when the bottom of the door is going to encounter a rug. Something to wipe your feet on before you track mud in the house. That snaps back up as soon as you're basically opening the door, allowing you to clear over that rug. What exterior home of a house usually doesn't have a rug? Your mudroom's going to have one from the garage, whatever the case might be. But that uniform lifting is advantageous, and again, because of the 2-to-1 lift ratio, because in the other designs where it drops and then knifes, what needs to happen? This needs to come up first. As the door is opening, you still have contact, and then this comes up. So you can, and you do, have a longer amount of unintentional contact with your seal on the sill, the threshold, the floor, whatever it is. So this uniform lifting, while it may not be perfect, it could be argued that it's superior to those other designs that need to operate like that, where you have a greater amount of time. If the rate that I'm opening the door is uniform, I've got less contact per thousandth of a second with the PDB product than I do other products. What I said earlier about automatic door bottoms generally don't break. They generally don't just stop working. People generally break them, and how they generally break them is that they push them over a rug or a shoe. If you've had children, I have, you come home and as soon as you start to open that door, you feel resistance. You know one of the kids left their shoe underneath the door. So now the problem is, you've been at work all day, you just want to get inside. Maybe you push a little further. Maybe you push even further. Well, that's what's going to break, either tear a door sweep or break an automatic door bottom. So you don't want to do that. This is a bit more advantageous because I believe it gets the drop bar up into the housing using less degree of opening of the door itself. So if you get that snap back up and you hit that shoe, you're tucked back up in pretty nice. That uniform cycle also makes it ideal for sliding doors. In this day and age, a lot of doors are sliding now compared to 10, 20, 30 years ago. There are many more sliding doors. Sliding doors are nice, whether they be surface-mounted sliding or pocket doors, because they don't consume a lot of the footprint of your space. Tiny homes and homes that are smaller, you're not losing a lot of design possibilities when you have to swing a door out. If you're just sliding it, you're not using up any of that floor space. In handicap compliant applications, you've got to have 32-inch clear between the stops. Sliding doors can hit that target really well as well. They're usually a little bit wider than average, but you already have a wall there anyway. You're not taking away from the available square footage really anymore when you have a sliding door. So this uniform drop is ideal for sliding doors as well. Because it just simply reduces drag in those applications, especially, well, in both. You know, if you do this in a sliding application, yeah, you're dragging this. With the Parker door bottom, there's less drag. Moving through my list, on seal to solve multiple problems. Well, one seal to solve multiple problems without needing multiple part numbers. So they're using this EPDM. The EPDM is going to be a tremendous all-around product that's going to be conducive to attenuating acoustical energy. It's going to act very well at just simply keeping water out. It's going to do a really great job at extreme temperatures, hot or cold. It's durable in the sense that it's reasonably abrasion resistant, and yet it's easy to trim and cut with a sharp blade. So the insert itself is simple because, well, we don't have to talk about silicone or closed cell neoprene versus open cell neoprene or thermoplastics or brush or polyurethane. You know, the approach of the Parker door bottom is, why do you need a different seal? I mean, I can tell you why I might want bristle. Bristle would be nice, and it's possible that they could do that at some point in the future. But if you have if you're installing the door bottom in an application without a threshold, and you have an extreme pitted concrete sill, this concrete sill's been getting stepped over for decades. It's literally pitted. Those brush are nice because they get inside of there, into all those particular areas, but admittedly there's just not enough call or requirement for brush to make it something that they would design around. So the EPDM synthetic rubber that they have is really, you might not need to consider any other insert, quite frankly. Now here's a reason to buy the Parker door bottom that is on the list of all these items I came up with. And it's basically designed, supervised, and assembled by experts in the field compared to companies who don't necessarily employ experts in the field. Now, I've been to the factory. I have literally witnessed the machines making the parts. I have spoken at length to the people who have taken the idea of the automatic door bottom and literally brought it to life through industrial design. I have spoken to at length the people that are assembling it. I am standing next to and conversing with the people as they're putting these together. And I'm there literally studying how they do it, knowing that at some point in the future, I'm going to be back in the United States and not in the south of England. and needing to do it on my desk for a video. There is something to me that is worthy of consideration when the people putting the hardware together are truly expert at what they're doing. They know what they're looking for. They know what it needs to look like. They know how to put it together. They know how to troubleshoot it. They're not just checking it off a list. If they're, so I find that an advantage. End covers are included with every door bottom. This model, the PDB411M, has the end caps installed. I have them installed. Here's one. Here's the same item without it installed. Okay, a little bit easier to see how it works without the end cap. But why do we need to state that end caps are included with every door bottom, regardless of it being surface or mortise? You know why? Because not every manufacturer includes end caps. And in fact, there is one that I can think of now that says, oh no, we never include end caps. And in fact, we don't make end caps for that. Mortise mount, like this, only larger, and an interior designer called me and said, what in the heck is going on? They didn't buy the door bottoms from me. I'm almost glad that they didn't. What's going on with, there's no end caps on this model. They told me they're not available. And I said, you're right. They're right. They're not. They have no response to you for the fact that when you mortise your door, you're going to see that all the time. You open that door and look at the edge of the door, you're going to see this all the time. Now, what would you rather see? Tell me, which end would you rather see all the time? Okay, so I'm going to go with this being the answer. So, all kidding aside, it needs to be mentioned. Not every manufacturer offers end caps. Parker door bottom is standard with that. Very low closing force. Here's reason number 10, believe it or not. Very low closing force will not interfere with ADA compliant door closers. You'll see later in the video where I install it on a screen door closer, on a pneumatic screen door closer, and sure enough, it pushes it all the way closed. And if I didn't have the latch on the door, it would pull that door all the way closed. Later in this video, I put a force gauge on this as well. And I can tell you that it's below 5 pounds per inch. Why is that important? Why is 5 pounds important? Well, if you have a door that's handicap compliant, you know that the maximum amount of pounds of force to push that door open is 5 pounds. As LCN said to me, a door closer manufacturer, and Brian Parker doesn't make door closers, so we can name drop LCN. Rich, with a reduced opening force comes a reduced closing force. The problem was, the reason I was speaking to LCN is the doors weren't getting closed. Are they handicap compliant? Yeah, of course they are. They're size 1 springs, basically. Very easy to open. But the problem with that is there's not much force in the closing action. If you have a fire-rated door and a handicap door, you need it to be 5 pounds, and you need it to close and latch. This model is below 5 pounds of force required. I think it was 4.7, something like that. So we know, because I've tested it with a scientific piece of equipment, something digital, that it will allow you to be compliant with both requirements. I can assure you that many, many, many manufacturers, if I were to take their automatic door bottom and push on it with this finger, I would not be able to depress it. In fact, there are many manufacturers that you have to put it on your desk, and then you have to stand up and use all your energy to get that to push down. Customers would come in the old days and want us to show them how the bottom dropped. We'd have to stand up and get it on the desk and force it down like this. And they say, boy, that takes a lot of force to push that down. Oh, yes, that's because of the flat spring and because of the way that it knifes down, and lots of force. I have no idea how much energy I could put into it as a 22-year-old, put onto that, but it was quite the exertion. So very low closing force, so low that it will allow you to remain compliant. 9/16 drop capability. Someone always asks, how far will it drop? Now, Brian will tell you, ideally, 12 millimeter is the idea. That's about 7/16. You don't want to have this drop any more than necessary. because you don't really want to compromise the internal. You don't want that drop bar to exceed or come out of its housing any more than you need to. The point being is, ½ inch is ideal. It'll go to 9/16, but ½ inch, let me back up. ½ inch maximum is ideal. It'll go to 9/16. In my opinion, you're going to want to be closer to 5/16, something in that range. Later, when I install this, I basically just put it on the door, fit it between the stops with the door closed, and just screwed it to the door, realizing that I was pushing the door bottom down a bit, so I was curling over the material, which meant I had to adjust it later on during the installation component. But you would just measure what you want that to be. You could take a piece of 1/4 inch shim or, a couple of whatevers and place it on the bottom of the door and just shim that up. Now, this is the mortise type, so you don't have to think about that because you're going to be mortising it and pushing it right to the bottom of the door. This is automatically going to give you everything you need. This is going to assume, obviously, you have at least a 3/16 of an inch clearance because that EPDM is already hanging down a bit. But like I said, 5/16, 3/8, that's going to be a really good spot for you on that. So ½ inch max ideal. Keep that in mind. Some people, this will not work for someone that needs a 1 inch drop. It's just not. Or a 3/4 drop for that matter. Unless, of course, you try to tug that down on the opening. Or if it's surface mounted, you drop that down a little bit further than it would normally come to. And if you've got a 1 inch drop and you need to hit that, you're going to need somebody else's product. But at the end of the day, that is a very unusual circumstance, and some would tell you that you would be better off replacing the door. Now, that's unrealistic, but nonetheless, that would be a reasonable response, actually, because you've got a door that's got too much undercut to begin with, or clearance. Clearance is the right term. Now, reason number 12, slide cover conceals fastener heads. Now, later in the video, you'll see the surface mount. You're not going to get color options on the mortise because you'll never see this. But if you imagine this without these bottom flanges, that is the surface mount model. The 3-footer is a little bit easier to look at because it doesn't have all those decals. They are bringing to market slide covers that are going to allow you to change that. Black, dark brown, that kind of finish, custom colors, as I had said earlier. Now, why is that neat? Well, you might say, well, I don't want a slide cover. I just want it dark browns anodized. Well, go to a hotel that's 20 years old. I've spent a lot of time at the Chicago Hilton at O'Hare because if I fly into Chicago, I just stay at the airport because then I don't need to leave if I'm just going to go do something and go back to the hotel and then the airport the next day. That hotel was built in the 80s. Don't quote me. I remember before it existed. But that hotel is really old in the sense of, it's an older hotel. All of those door bottoms are beat up. They're scratched. They're very unsightly. My argument with the slide-on cover is it gets scratched, damaged, beat up years down the road, peel it off, put on a brand new one. We've already talked about a grade 1 rating on this. We've already talked about 27 years if it's cycled 100 times a day before you hit grade 1. We've already talked about a 7-year warranty. New slide cover, which adds a very small amount to the overall cost, and you look like you've got a brand new cover. And the inserts can be replaced, as I had said earlier. Different colors as well. Where do different colors come into play? Well, maybe a hospital. Movie theaters will want unusual colors, purple and red and green and fun colors like that because they've done some sort of finish on the doors to the theater itself, and they want that to look, you don't want the hardware to detract from what you've done to those pairs of doors going into the theater. Now, the other thing about that slide cover is it's going to conceal the heads of the screws. That is a claim that others will not ever be able to make. You're always going to see your fasteners on other manufacturers' items. With the PDB, that slide cover comes on and you'll never see the heads of those screws. That's elegant, very elegant. Now, the Parker door bottom, this is reason number 13. You can use these very easily on center hung doors. So a center hung door, offset hung and center hung, those are the two terms we want to think about. It has everything to do with where the vertical axis of pivoting falls in relationship to the door, some point on the door. An offset hung is generally, when you look at the door in elevation and you're going to pull it towards you, that vertical axis of pivoting is generally 3/4 inch off the face of the door, and then some dimension from the hinge edge. It can be about 3/4, or it can be about 3/16. Doesn't really matter, or it can be 0 if it's a butt hinge, basically. But it's about 3/4 off. That's the vertical axis of pivoting around which the door rotates. In a center hung application, that vertical axis of pivoting is now down in the center of the thickness of the door, that imaginary plumb line. That's the point of rotation that the door goes around. This design will work very compatibly with center hung doors, whether it be surface mount, or if you have a thicker door than average, you might be able to force to fit in the mortise mount, because if you've got center hung pivots, you're vying for space in the bottom of the door. Because of the uniform drop, this will work very well. Plus, we can make for you, or have made for you, we won't make them here, but custom strikes. As that door comes into contact with the jamb, the plunger, it'll hit that strike and start to depress. Okay? And that would work out really well. So you'd use it there. Also, speaking about center hung doors, absolutely use these at the top of the door as well. No reason you can't. In fact, technically, there'd really be no reason why you couldn't, mechanically use them on the stiles, although you've got all your other hardware happening there. But you can easily use it at the header and easily use it at the sill, just the same way. This item does not care if it's installed like this or like this. It just doesn't. It's going to work either way. Either way, it's going to work. Not a problem. Okay, so reason number 14, narrower mortise for the M model, removing less of the door. Now, what's better? A deadbolt that you'll install into a 1.5" diameter hole, or a deadbolt that you'll install into a 2 1/8 inch diameter hole? What does a deadbolt have to do with it? The answer is the 1.5" hole, because you always want to remove less of the door. This is smaller, and we're going to look at the dimensions of this, but this is much smaller, thinner. It gives you all that grade 1, 7-year warranty in a much thinner, slimmer case. So you're removing less of the door. In fact, with that surface mount, you can look at other manufacturers' automatic door bottoms, and they're positively obscenely large. They're huge. They're thick. They're 1 inch thick, or even maybe even a little bit greater. This is far smaller than that. The thickness of this body is 9/16. Technically, if I put my caliper on it, it's probably less than 9/16. So it's very thin. You get all that performance in a very thin, narrow channel. That means you're removing less of the door. That's advantageous. Now, speaking of door thickness, what will this go down to? Well, that, right out of the box, is not even 1.25 inches. Other manufacturers' hardware is not going to work on doors generally that are thinner than 1.75 inches, because the width of their bottom flange, and this is where you would fasten it, there just aren't holes drilled in this, this is wider, or about 1.75 inches. So if you're doing 1 3/8 doors, you have to think about the door bottom you're going to fit on there, and test and check and review its dimensional properties to make sure it will fit. Parker door bottoms, don't even think about it. You want mortise in an 1 3/8 door? You got it. Nothing to worry about. There you go. It's going to work. Okay, that's advantageous. We had talked about it being number 15. We talked about the thinner unit for a surface mount being, less unsightly. I believe that it is. Next time you're in a hotel, there's probably going to be the larger than average, or absolutely in a commercial application like a airport. Notice the automatic door bottoms. They're really big. They're just huge. They don't need to be. It turns out. 15. A thinner surface. Okay, sorry. 16. Actuator button made of durable synthetics so as to not mar, deform, or dent wood frames, eliminating the need for an unsightly strike. So what that means is this plunger here is some sort of high-tech plastic. This is going to be on the hardness scale, not as hard as the wood that it's making contact with. This is not going to dent or deform that wood stop if you're doing a wood stop. manufacturers will include a piece of metal or a large screw head that you have to install and maybe even countersink into the wood stop to prevent that plunger from deforming or denting or creating a divot into the face of that wooden stop over time. That would be an advantage of what this is made for, or made of. 17. The even drop of the drop bar assembly leaves less unprotected spaces on the hinge side of the door compared to competitors. What I'm meaning by that is, if you take a standard automatic door bottom by another manufacturer and you are able to push that pin in, you'll notice that the drop bar, well, we know it almost never drops down uniformly. It does come like this and then this. But what's really happening is that drop bottom actually comes away as it's coming down. There's a very small gap over here every single time. Customers would say, you know, that insert's not coming out, not hitting the jamb when it's tucked up into the door, but when it's closed, I can see it's hitting that, and I can tell. And it's because that drop bar is really moving laterally as it moves this way. It's always moving laterally. This design completely eliminates that. 18. STC rated 46 right out of the packaging, and when used with the balance of the tested assembly, it can be used on openings up to STC 52. That goes back to much earlier. You just want to keep the sound down. Not only for you, again, compared to the person watching television, but they really don't want to hear your conversation either. They don't want to hear the Zoom meeting that you're in. You know, so hardware that allows you to hit true sound transmission control levels is advantageous right out of the box. 19. The combination of aluminum and EPDM is the ideal component which provides a combination of components which provides both absorption and insulation. It turns out that aluminum in the process is advantageous for sound transmission control. So you're going to have the insulation properties of your EPDM insert, but then you're going to have the absorption properties of the aluminum bar itself. And that 1-2 combination is what's giving you not only STC rated hardware without even knowing that you're getting it, but it's giving you that security aspect as well. Okay. 20. Anodized as a standard finish as compared to mill finishes. And then again, custom finishes on those surface mount models via that slide-on cover. So what we're saying is there's no such thing as mill finish from Parker Door Bottom. All of their parts are anodized. Anodized, that's the wrong item. Anodized is this is anodized, a finished process over raw or mill aluminum. You can get many door bottoms that are just mill. You know, that's okay for the back of a warehouse, nobody cares. But do you really want unfinished aluminum, raw extruded aluminum on the front door of your house? No, I wouldn't. I would want it to be anodized. So that's an advantage. Their standard product is anodized. 21. Eliminates the need for a threshold when installing one would not be practical or possible. Many manufacturers of automatic door bottoms tell you our automatic door bottom has to be used with a threshold in order for it to be effective. Not this. The application that you'll see I install this on, it's impractical to install a threshold. This seals right down against my flooring condition is what it is. Very advantageous. It allows you to get away with having to install a threshold. 22, I had mentioned earlier. 2-to-1 drop ratio brings the drop bar back up into the housing with very little movement of the door. 23, and it's the final advantage that I can think of. I had said it earlier. It can be installed at the top or the bottom equally as well. Doesn't matter. So there's 23 reasons why this is a superior product. Now I'm going to add as a 24th reason, when you compare the pricing of the Parker door bottoms against other door bottoms that we sell, I think when you take this list of key features, you're going to say dollar for dollar, that's the one that I want. In my estimation, you're going to spend 50+% more for an item that may not be considered advantageous at all, and you might be spending 50+% more just because of some inherent defect in the existing door and frame. So lots of reasons to consider this. The next part of this video is going to be a review of all of the documentation, where we're going to switch to the screen view and we're going to take a look at that. So let's move on to that now. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. All right, let's dive into all of the several and many attachments that are here. So this is going to be installation instructions. Let's slide over that. Let's look at the cut sheet. So obviously much of this is going to be a duplicate of what I've already said. And I'm going to demonstrate this mechanism to you after we leave the screen view. This is the secret recipe, so to speak, on this. So drop seals play a vital role within the built environment. They are the only successful and sustainable way to seal the problematic threshold gap at the bottom of every door. At PDB, Parker Door Bottom Seals, we have successfully designed, patented, and manufactured a high-performing alternative to the traditional spring drop seal. They are the only manufacturer that offers a complete fire, smoke, acoustic, sustainable, and security sealed-in-place solution. There is no equivalent on the market. And you'll note that earlier I did not mention its ability to be installed on a fire door. You know, that's something that you're going to need to be able to do. This can do it as well. What makes it different than other bottoms? Well, manufactured in the UK, I don't know that necessarily makes it different. But there are two unique innovations. Full aluminum drop bar with EPDM rubber shrouding, which seals the entire threshold gap. This has, I think what's being said is this EPDM on this side and this side, broken up by this piece of aluminum. You've got insulation, you're insulating, you're absorbing, and then you're insulating again. So that acoustical energy is going to need to travel through all of that material, and it's going to be compromised in its intensity from the insulating material, the absorbing material, then the insulating material. A globally patented arm-controlled mechanism that creates a consistent, controlled, unilateral downward pressure across the whole drop bar. Absolutely. And I have a cutaway sample here, and I will show it to you in a moment, or when we switch back. Let's take a look and see. Interior doors where there is no threshold? Yeah. Do you really want to put thresholds on interior doors? No, you really, really don't. Ideal for that. Exterior applications, lots of modern homes, lots of construction that's being done. They don't want a threshold down here. They don't want to be bothered with it. They don't want to be asked how they're going to keep the rain out. They just want it to happen. There's your solution. Automatic door bottom seal that requires no power connection and plays an integral role in ensuring all door sets perform at their optimum specification. Easy to install in both refurbished and new built projects, meaning you can install these on existing openings and brand new construction. Automatically adjusts to uneven floors and requires low maintenance throughout its operational lifespan. I would say that you have the ability for this to tailor to an uneven floor within a very small amount, 1/8 of an inch. It's not going to tailor to something grossly out, because this is part of that linkage I mentioned earlier. You can't see the rod here. In fact, it's not drawn in at all. There's a vital component that's not shown here. When that drops, it drops uniformly. It does so as a result of the design of the product. And it's a result of the design of the product that will prevent it from being lifted ununiformly. So, yeah, you'll get a little bit of tailor around it, but not too much. Fire and smoke protection. Now, this is a European standard, and would technically not be permissible for use on one that's requiring a UL requirement. Matches door rating under sound control, matches ratings up to STC 52. Sustainable. Everything inside of this product can be recycled. Plastic, aluminum, steel can all be recycled. Enhanced security. The only drop seal to offer a unique benefit which stops unauthorized access. Well, that's not true. There are other manufacturers that have that aluminum bar as well. But the important part of the Parker door bottom is that it's standard with the model. You don't have to think of one giving you the additional ability to have a security seal at the bottom. This every one you order will have it. No threshold plates required, unobstructive access. Pest control, complete protection against pests and vermin. Absolutely. In the sense that you've got that piece of aluminum. You know, a rat, a mouse, we've got a lot of experience with those critters here where I am. They will chew through this rubber. If they can smell food on this side, they will chew through that and get through it. If they can smell it. They will not chew through that aluminum. I've seen them try. I have seen the evidence of them trying to chew through plastics. I've seen the evidence of plastics being chewed through. Never aluminum. 6 years performance testing in the US and North America. 7-year warranty. Reliable, consistent performance. Easy to install. Low maintenance. I'd say no maintenance. Aesthetically pleasing. Yes, I would agree with that. Residential, commercial, hotels. I'm not sure what PRS stands for. Education, hospitals, healthcare, student accommodation, dorm rooms, hospitality. Sure. Absolutely. Let's go on to the next document. Data sheet. This is the same information. This could be considered, you know, the second document in a cut sheet. I will leave that all to you to review. We've gone over this. Here is a parts drawing. It's going to show more than 10 or 11 pieces, but here's where I'm coming. Plunger. Arm. 1, 2, 3. That's the rod I mentioned. 4. You've got these flat springs and the guides. 5, 6, 7, 8. Okay. This is the linkage between the arm and the plunger. I'm just considering that all one part. You know, you've got less than 10 parts here, and that's what's going to happen. Really easy. And you're going to see in the video how simple it is to resize it, in the sense of, like I said, if you've got 3-foot units and it turns out you've got 2'6" doors, no problem. Let's go over how to cut them all down. And basically what you're going to do is you're going to remove a single screw, which is not shown here. That will allow you to then slide the entire assembly out containing all of this. You're going to have to remove this, loosen this screw, pull this arm out, shift this down to the right location, cut this, re-drill the hole to hold that single screw that holds this in. You might have to re-drill a hole or holes to secure it to the door itself. Oh, no, you wouldn't. This is a mortise model, but in a surface model, you might. And you're done. That's it. It's it. It's super easy. If you need to cut any of them down by 4 inch or less, just cut. Don't worry, you're not going to hit anything, because they hold this assembly back far enough, a minimum, to allow you to net 4 inch off every unit. This is the surface mount cut sheet. So basically, it's going to give us all of the same performance requirements, but it's clean. It looks nice. It operates the same way. 9/16 thick, as we had measured earlier. You don't have to compromise the door construction. You don't have to route the door. That's a problem for most people. They don't have a router nor the knowledge to route a channel in the bottom of the door. You want to make sure that you are not violating any fire ratings before you prep a door for a mortise model. This allows you to sidestep that. And these are the instructions in terms of how to go about installing it. Remove the PDB, and we'll go back to the mortise mount. Remove the unit from the packaging. They want you to take the door off of the frame. Sure, I'm lazy. I didn't do that. Measure the width of the door. Great. If cutback required, which there probably will be, remove. There's going to be, if you're mounting it like they show here. This actually shouldn't be drawn this way. unless it was center hung. I mean, this could be center hung, but this is going to be held back because this is going to be on the push side. This will be held back, whatever the thickness of your stop is, plus maybe 1/8 of an inch. So you'll need to cut it back in almost all instances. Fit the PDB411S, as for surface mount, onto the outer side of the door panel with the actuator button on the hinged side of the door. Please ensure the underside of the PDB411S is flush with the bottom of the door. Mine basically was. So makes it really easy there. Fit the 411S to the door panel using screws. Now, when they say the outer side, they're assuming doors swing in. This has to be installed on the push side. The push side. Can't be installed on the pull side. Can you make a modification to install this on the pull side? You could. You'd have to figure out a way to mount something onto the face of the frame that will make contact with the plunger as you pull the door closed, and then mount this on the latching side. You could do that. Once you've got it attached, rehang the door, ensuring that the actuator button is on the hinge side when it's a push side mount. Adjust the drop bar accordingly to ensure that the threshold gap is fully sealed when the actuator button is engaged. Start with the button screwed in completely to avoid over-adjustment or damage. You don't want to over-compress those arms. And then you modify the projection. You turn that out until you get the proper drop. 15 millimeter max, again about 9/16. Here you go. Do not cut the 411S shorter than 100 millimeter. 100 millimeter is 100 divided by 25.4. So basically they're saying don't cut more than 3 15/16 off of the unit. Well, 4 inches is what they had said, as it will affect performance of the seal. Any cutting must be done on the non-actuator side or the lock side of the door in a push side mount. Now later in this video, put my force gauge on this unit, and that's how I know it's below 5 pounds. This is the same door bottom in my freezer. You're going to see after that test of the force gauge how many pounds of force it takes when this has been in a freezer for 48 hours. So just for the sake of knowing it, we're going to know what that is as well. So that'll be fun. Now back to our fitting instructions for the mortise, what they call fitting instructions. Check the door and seal rating requirements. It's the same language. For mortised applications, the door will need to be channeled or mortised at the door bottom. If the door is not supplied with this feature, a channel needs to be cut before attempting installation of the drop bar. Do not compromise the door construction. Make sure you're not violating the integrity of the door either physically or from a ratings and certification perspective. Remove the drop seal from the packaging and check maximum cutback size. You want to make sure that you're going to trim this if you need to. Measure the width. If cutback is required, do so. Fit the 411M into the mortised groove with the actuator button on the hinge side. So, how wide are you going to route that? Well, if it was me, it would probably be 5/8. Because I had measured that earlier at 9/16. I'm going to put my caliper on this right now and tell you exactly what it is. My caliper tells me that this is 0.57. So 5/8, not more than that, because that channel that you're going to route, 5/8 is 0.625. 0.625 minus 0.57. That's 0.055 divided by 2. That's less than a 32nd of an inch. So I would think that that would be agreeable for installation purposes. In terms of the depth, yeah, you're really not going to want to mortise any deeper than needed because these end caps don't cover. Yeah, you're going to want to be really precise with that. you're not going to want to go any more than, no more than 1 7/16, 1 3/8, 3 6/16. I would probably say 13/32 if I was going to be more technical about what I'd want to put that at for a depth. The design of this is not going to be very conducive to a much wider than needed or taller than needed prep. They don't give you that size, but I've measured it, and those are the dimensions. Cut it to length. You will have to. Mortise the door, pre-drill your holes, attach it, rehang the door, and then adjust the bottom accordingly. Really easy stuff. It really is. The mortising of the bottom of the door, that's a different video. I can walk you through how to do that as well. Now, there's some acoustical test reports that are here as well. This is when the Parker door bottom was a standard item offered by PEMCO. Well, the license for Parker door bottoms expired, and PEMCO didn't renew it. So the PDB411 is what it was called at PEMCO. It's still a PDB411 STC46 right out of the box. Well, actually, with the other PEMCO items. Now, this unit is STC46. If you want to have an STC46 rated opening, you do have to treat the rest of the cracks that are in the door. The addition of the door bottom alone doesn't give you STC46, but when used with these other items with which it's been tested, you then have a complete opening. So if you want to hit STC46, the Parker door bottom hits that. But you have to put up the rest of the material as well. I feel like I was not completely direct about that. This is the test report that I'm not going to read to you how, how it was executed, what was used, what the standards were for deriving at a baseline. So you can read all of this. But nonetheless, this is the actual document from the manufacturer. So very, very interesting. Now let's switch back to the screen view where I'm going to show you the operation of the arms, and then we're going to move to the nuts and bolts of this. Let's do that now. If you've made it this far into this video, you must be determined to see it through to the end, and we appreciate your hanging in there with us and watching this entire video. It means a lot. It takes a lot of work to create these videos in the sense that, it's time taken away from doing other things. However, the advantage for me personally of creating these videos is the fact that it does allow myself to either learn about something new, to reacquaint myself with something, or to reinforce what I believe that I already know. Any comments that you might leave down below would be greatly appreciated. Thank you. Okay, so I was being a bit coy earlier. I was always holding this so that you couldn't see the cutaways. Now, I asked Brian to send me this cutaway sample. I saw this in the factory, and I said, boy, Brian, I need one of these for the video. And it's because we really want you to understand how these work in the sense that they're really simple. So what's happening, and you're going to see it when I take the unit apart, but when I push that button in, the only thing that you're seeing is that arm deflecting like that. So this arm right here via the screw, that's the drop bar that's right here that you're seeing. That's the drop bar. Okay? So the head of that screw, and that's a 2mm screw, by the way, what my fingernail is touching, that's the drop bar. You can see it vanish. So again, plunger is connected to... I asked Brian to send me a couple of these arms as well. My intention was to put these in the freezer, and I realized I'll just put the whole item in the freezer. So what's happening here is these arms can only deflect. Plunger gets pushed in. This goes that way. This is forced down. As I move it this way, this is forced down. And I'm being a little exaggerated, but that's how this works. And I'll tell you, the challenge that they had in the factory was getting these dissimilar materials fused together. And they were quite proud of the accomplishment of achieving that. obviously these arms don't fail. You've got a 7-year warranty. You've got grade 1. They don't know how many cycles it would go to because they stopped testing it. It was obvious that you don't need 100 cycles a day, 27 years. No one's going to be here to tell you that it broke. That kind of logic. So it was quite the achievement of getting these arms manufactured. So plunger is pushed in. The rod is sticking in this hole. And that steel rod, I believe it's steel. It's not aluminum. It was too resistant to cutting when I cut it later. I believe it's steel. I don't have a magnet here to put on there. That's connected to the other arm. Plunger. Both of those arms now are forced to deflect because this part is being pushed. Okay? That's how that's working. Really great stuff. And you're going to see this at length as we do the disassembly, the analysis of all the parts and how it all works. Great little tool. If this little sample doesn't sell these door bottoms, nothing will. So now we're going to switch to taking one apart after looking at the cutaway sample. We're going to identify all the pieces. We're going to figure out what needs to be cut and how to cut, and hopefully it all works out. I've never done it before. I've never taken one apart. I've never cut one down, and what you're seeing is me discovering how to do it as you're watching me discover how to do it. We're then going to get it installed. We're then going to look at the force required at room temperature and at freezing. How much it takes to depress that. Why do we want to know what it is at freezing? Well, I'd like to know how it changes. Folks up in Chicago right now at the very end of 2022, they've got single-digit weather. I'm from Chicago. I'm no stranger to single-digit weather. Things stop working when it gets that cold. It's weird. Things just stop working. No explanation other than the fact that it is bone-chillingly cold. Things just stop working. I want to know if that stops working when it gets to below freezing. I don't know what... I don't have a thermometer in my freezer. It may tell me what it's set at. You know, what's a common freezer at? 17? Something. It's obviously below freezing. So we're going to get to that as well. And then we're just going to wrap it up. Thank you. Let's move on. Regarding the links to ads that you might see in this video, we do apologize for any interruption to a smooth viewing experience. And hopefully the ads that are being presented to you are related to the base product. And if there is something, feel free to click on those and perhaps consider taking a look at what that other advertiser is promoting. Let's get back to the video. And the brilliant aspect to the Parker door bottom is going to be the linkage that's here. And that's really what gives this model its absolute uniqueness. It's quite the engineering marvel in the sense that you've got disparate pieces of material that have been fused or brought together. And what happens as a result of the operation of this is you get an even drop of the bottom down with that very low closing force. A very robust and durable item. This model, this 24-inch model, has 2 of these cutaways on it. They're literally identical. So let's continue on. Let's take this apart and see what's inside. Okay, so let's get started with the disassembly of this Parker door bottom. Now, I've never done this. This is literally my first time I have witnessed these being assembled in the factory, and that was 3 months ago. So let's just see what happens. So this is a good example of what it would be like to be you receiving this door bottom, and you need to size this. And part of the elegance of this entire system is that everything on the inside is really is designed to be extremely simple and straightforward, as this cutaway shows. So I believe this screw here is going to need to come out. So we're going to remove that screw, and we're just going to see what happens, because I honestly do not remember what happens at this point. So I've got that screw removed. Something would tell me that the entire drop bar assembly slides out, and that is indeed the case. Yeah, okay. Yeah, so it's sliding out. Yeah, super simple. exactly the way that I recall. So all this is just a piece of aluminum. Housing is really all it is. There's nothing to the exterior. So the business end of this is comprised of just a few simple components. Yeah, and cutting this down would indeed be very simple and straightforward. And what I mean by that is, as I study this, you've got your threaded plunger here. Okay, that's going to get threaded onto the end here, onto this arm. So we've got the plunger bolt that's just simply threaded on. There's really not too much that we need to think about that. It does thread in and out, as you may or may not be able to see, but I can thread that in and out to adjust the projection. And then what we're going to have here is going to be the arm, or the linkage arm. I have one here. I have a couple of them sent to me from the manufacturer for testing. The wonder of these was the fusing of this dissimilar material. Okay, so these two arms, there's two of them in each unit. Obviously what we have here is the assembly to adapt or to add the plunger here. Okay, so pretty straightforward. Okay, looks like we have a couple of Allen drive screws here. And I can tell you right now that this is really simple and straightforward. So what I mean by that is we've got the arm. The arm is what is, when we push the plunger bolt in, the arm is what's creating the drop. So in our disassembled item, when the plunger is pushed in, these arms would not be, of course, deflecting up. They would be, because they're concealed, they're captured within the aluminum case. It would obviously force the bottom to drop because they're kept. Yeah, they're kept in that position. Yeah, okay. So this bar doesn't do anything. It does everything. It doesn't what it does is it keeps, it's beautiful. It keeps the two arms connected at all times. This specific dimension never changes. This piece of rod is not changing at all. And when you depress that, because this rod is connected to the other arm, it clearly can only then force the unit to drop as a result of this fixed linkage. The arm itself is it's very simple in the sense of once you see it, it's simple, but it's elegant in its design. So if I were to cut this down, first of all, this is basically a 3-foot length here. I would easily be able to cut this down 4 inches. I could cut all the way up to here, all the way up to here. 4 inch, I can trim that right away, no problem. But if I was in the field and I needed to modify these, it's going to be easy to do. But it's going to require a little more significant disassembly, but nothing too extreme. And let's go over that now. Because this is manufactured in the United Kingdom, I'm going to imagine that these screws that hold the arms on are metric. So I have a metric set of Allen wrenches here. I don't know that they are, but we're about to find out. Yeah. Yes. I would say that that is yes. 2 millimeter is what it appears to be. So you're going to need a 2 millimeter Allen wrench. I'm just going to simply remove this screw. And I already know, based on my visit to the factory, what has to be done to do this, but I'm not going to give you the end of the story till we get there. Okay, okay. Yeah, really easy. All right, so what's happened here is I've unthreaded the screw, and now when I lift this bar up, what we basically have here is this flat spring and a rod guide, I suppose is what I would call that. And it can be inserted into here anywhere. So if I were to cut this down, I'm going to need to loosen that screw to where I can pull the flat spring and guide down. Okay. I'm going to need to remove this arm from the rod. Okay, it just comes out. That's easy. Got our arm removed. If you want to put the material, kind of stage it back together the way it goes. Now at this point, I only need to remove one of these, one of the arms. But for sure what's going to happen is over here, I'm going to have to lift the rod out. Okay, I witnessed these being manufactured. You're going to need to cut this to the proper length that you require within reason of, you know, you don't have to be to within a 1/16 of an inch, because all this rod has to do is connect to the other arm that resides, you know, over here, if you will. So if I were to cut it, let's say that this 3-foot unit I needed to cut to 28 inch. Okay, well that's going to be 6 inches off. So I'm going to cut this all back, say 6 inch. Well, this rod I could cut to 6.5 inch. If the arm is a 1/2 inch or 1 inch from the end, it's not going to matter. So long as they're within reason, a reasonable distance of the end, I would say a couple of inches. So the point is when I cut this rod, I'm really not concerned about it being absolutely accurate. So what will need to happen is the rod will have to be cut, the end will have to get turned over so that it can be placed into the arm itself like this. Actually, it's in the second one, right? Yeah, this one has 2 holes in it. I don't know why. Probably has something to do with manufacturing, or they just don't belong there. Yeah, these both have 2 holes. I don't know why. It doesn't matter. I've got it inserted into the one that's the second hole, so to speak, from the end. And I'm not really worried about what length I would cut this to. So I would have to cut the rod. I'd have to turn it over, and I would, quite frankly, I would likely just do it in a vise. I don't recall how they were doing it. I don't think they were doing it by hand. That wire, this rod appears to be relatively thick for just turning it, curling it over by hand. I would probably use a vise and a rubber mallet and trim that down. And once I had that cut to length and then turned over, I would cut my drop bar down. I would reinsert my flat spring with the guide. I would probably reattach my rod, and then I would position this exactly where it needed to go in the length of the unit itself. Okay. Now this is quite a bit to cut with a hacksaw by hand. There's no doubt about that. So I'm not going to want to cut that by hand. I'm going to want to cut this in a chop saw. That's a lot of aluminum to cut through. So I would be doing this with a chop saw with a carbide blade in it. So it would be the next step. Once I had that cut to length, I would cut my housing to the same dimension. I would have to get my rod cut down and turned over, and that would be that. So the next step to do, and we're going to go about doing this. So this unit was actually a little bit greater than 36 inch. And we can get it down to a 2'8" door, but that's no good because we don't have to cut the rod. Let's take it down to like a 28 inch, like I had said earlier. If that'll be adequate? Let's see, 28 inch. Yeah, sure, that's going to be no problem. So I'm going to want to net I'm going to want a net result, and as I'm studying this, to see what needs to happen here. And I apologize because I am literally learning this as we go along. Now the roll of that screw that was in here is a bit of a mystery, so I want to solve that first. I'm going to slide this back together, and it just slides in nice. I mean, I'm missing part of the mechanism, obviously. Sorry, I've got that put together wrong. That's better. Yes. Okay. Just bear with me as I continue to try to figure out this assembly. What's unclear to me is the roll of that screw and how it's keeping everything attached. Yeah, I can see it there. Let's put it back together because something is eluding me in terms of how this is held captive, and I wonder. Let's put the flat spring and the arm back together. Okay. Yep. So all we're going to do is thread that back together because I want to be sure that I understand the principle of how this works. I haven't tightened it because I don't think I've got my rod. Yeah, okay. The rod is in the right position. So let's tighten this down. Okay. That's put back together. Let's put the tool over here. Let's slide it all back together. Let's make sure it works right. I suppose this part of the video would have emulated me already cutting the unit down. Sorry. Yeah. Yeah. Because the process of getting it put back together means that we need to ensure that it's going to work. Well, it sure works. Oops. It's moving laterally on me. The purpose of that screw, though, what's it locking into? Okay, that's tight. Well, our unit certainly works without any trouble. The only mystery for me at this point is this screw is keeping everything put together, keeping it held together. The mystery for me becomes, we're going to have to re-drill that hole. Well, we actually wouldn't have to, because we're only cutting it down 6 inches. At least I don't believe we would have to. But it's still not clear to me what's keeping that in place. So, let's take it out and lay it on top. Yeah, so that's... that dimension, that item is... No, it doesn't appear to be critical. Aha! Oh, now I see. Now I see it. Yes, yes, yes. So, what it is... Apparently that screw is going into our guide that's here. I can see that clearly now. I can see that that's how this is. And that would absolutely prevent any sort of lateral movement. What wasn't clear is when the screw went through, what was making it such that the entire drop bar assembly could not shift laterally. And now I understand why. It's into one of these guides. But I'd like to prove that by looking at this unit that we have here, actually. Yeah, this one's right here. So let me put this aside. I don't want to reassemble it because we're going to cut it. Screw, tools, the tool we dropped, which we'll leave here. Let's take this one apart just to confirm how that's going. That this screw is indeed into one of those blocks. And if that's the case, it is then critical in terms of where you position that. So there must be a relationship between that dimension, the dimension of where the arm is placed to this position. That's obviously important. From where the arm is placed to here, because that's where that guide should be. So I've got the screw removed. I'm going to pull its 2 little end caps off. And this is a mortised version, by the way. So let's pull our assembly out. And I'll tell you, I'm not scared of these automatic door bottoms at all, because they're easy. But let's just discover this together. Yeah, you can kind of see it already. You can see the hole in that guide. So I pull that out. That hole is right there. That's what's preventing this from shifting laterally. It's held captive in this guide. Okay, quite awesome. So that does now tell me that there's going to be a minimum amount. And the manufacturer told me it was 12 inch, or maybe he said 14. Or maybe it was 18. I'll have to look. But based on what I'm seeing, it would be 18 inch. If I were to bring these two guides to within a 1/4 inch of each other. So I've got about 2 1/4 inch between here. Over here I'm at 19 3/4. So 17 1/4. So 18 inch would make a lot of sense for that to be the minimum dimension you could put this down to. If it's going to go down from there, you'd obviously have to affect these springs, the length of these springs. You'd have to tighten that up. You would have 2 1/2 inches there, 4 1/2, so that'd be 6. So yeah, 12 inch. If we made these spring lengths, if we cut that and re-drilled them and made them the minimum, yeah, you could get that down to 12 inch. That could be done. So that is the mystery. That screw is going into guide block, if that's what it's properly called. So I'll put this back together. And what I'm doing when I put it back together is... I'm just studying this myself first. Yeah. Okay. So what has to happen is your arm, your drop bar, is going to reside below this shoulder, below in this space. But your guide arm, your arm and this guide here, that all resides above that shoulder in that space. So that when you slide that back together, you have to do it in such a way that you get the arm portion up above. Yeah. At least I believe I'm doing it right. Oh. Yeah. Oh yeah. That goes together really well, actually. Yeah, that goes together really well. So here you can see it. You can see it here. You see that little shoulder right at the tip of my finger, right here. Okay, and you can see what resides above it. You know, our blue arm and our black guides. That all resides in the top part of it. When it goes back together, it's quite smooth. So, in order for me to hold this captive again, that screw is underneath the decal. I'm going to insert that back in. And the idea is that we're going to find that same hole in the guide, the black guide. Yeah, I can tell that I am. It went right in. So I'm thinking that what is going to need to happen is... Yep, works just like it did, without any trouble at all. What I'm thinking is going to happen is... Goodness, depending on how much you're going to actually cut this down, you're going to need to reposition that hole. If you're going to cut so much off, the hole where the where the limiting screw comes in, or the restrictor screw, that's where the screw goes into. That's on the inside, right here. Okay, into the black guide that's there. If you're going to cut this down so much that you eliminate that, you know, if you're going to take this 3-footer and cut it down to 24 inch, you're going to take 12 inches off, yeah, you're going to need to figure out where your position is from the end to the center line of that hole, and then re-drill and countersink a hole over here is what you're going to have to do. Okay. You'll notice that there are 3 screws here. That's going to be the fasteners to hold the unit onto the door. Then you'll have a 4th screw that will have that screw head in it that's going into the block. So yes, you're going to have to, once you know, we're going to cut, whatever I said, 8 inches off of this. We're going to have to reposition all of this, which means we're going to have to re-drill and countersink this hole over that dimension. So if... Okay, I had to... And we've got that video about to follow with what size that's going to be. And I have that tape measure put in there, and what that's giving me, sorry about my hand being in the way, but 29.5 inch is what that's giving me. This is the door that I'm talking about, the door from the office to the shop. And basically what we have to measure is the distance between the stops from here over to here. So we know what size we have to cut this to, so what we're going to do is just cut it with a, it's just a hacksaw is all we're going to do. So I know I've got to cut it to 29 3/8 because our distance between the stops is 29 1/2. So what I'm going to do is just use my vise, and the vise is really going to act as nothing more than, you know, an extra set of hands, basically. Okay, and I know that this is my latching side that's over here. Doesn't really matter, I suppose. What side is the latching side? It really doesn't matter. So I'm going to see which side is more advantageous for me in terms of what side I'll cut. Yeah. Yeah, you know, I would be tempted to say cutting from the, well, if we cut from the other end, we're going to have an unused hole. That hole that is where the screw was installed. Yeah, I'm going to, because of where those holes are located, I'm going to just keep, I'm going to cut from the side that I would, the opposite the plunger side. So that's the side that we're going to cut off. And make a little mark on our extrusion here. I'm going to turn it over because I want to mark on the face of the unit from which I'm going to cut so I can see. So we're just going to be at 29 3/8. That should be adequate. And I do like to give myself a line down the entire item, just so that I can watch to see if I'm cutting straight or not. A couple of pieces, I mean, you can use obviously wood, a couple of pieces of cardboard are all that for me is really adequate to cut this down with, because again, it's just a set of hands is all I'm really needing with the vise. You cannot put so much force onto that you're going to damage or crush the housing, because that's going to prevent it from actually working correctly. So you certainly don't want to crush it down too much. And all the cardboard's going to do is just keep me from leaving any marks from the vise onto the workpiece. Sorry about that ringing sound. Okay, so we've got that held in there well enough, and I can see my pencil mark over on this side. Okay, so I'm just going to start basically what's an initial score line. Trim my cardboard back a little bit. Okay. The purpose of going through that by hand was to actually have an understanding of what it takes to do this work by hand as well. Yeah, a fairly clean cut. I would dress that with a file ever so slightly because it's very, all but unremarkably out of square. Nothing I would really worry about. And for the purposes of this demonstration, I would just be taking a file and just cleaning that off. And quite frankly, there's so little there. A very small amount of file work. I'm almost tempted to say if any at all is necessary. Okay, so we have cut down our unit from the opposite side. I'm happy with that. Next thing to do is to cut our drop bar down, and we're going to be cutting it accordingly. Let's do that now. Again, we're going to mark it. 29 3/8 is our size. I'm just putting a pencil mark on this drop bar is what I'm doing, and then I'm measuring twice. 29 3/8. Yeah, we're in good shape. 29 3/8. Yeah, we're in good shape. Okay. Realize that I mark that on the opposite side of where I want to mark it. And now to cut the drop bar. Okay. Straight back and forth motion with the hacksaw is the way for this to work. The rake on the hacksaw blade is forward so that when you come back, you're scoring really, and then as you push is on the cutting, is the cutting part of the movement. much force on the aluminum. A little bit, the weight of the tool, the weight of your hand kind of is what provides the contact between the blade and what you're cutting. A good way to do that is to pull the insert out the opposite direction, or actually pull it out through here, cut it, and then slide it back. But you know, it's cut fairly. It's cut the way we like it. Okay, fairly clean cut on that piece. Yeah, happy with that. reasonably clean cut. I would probably dress that up with a file real easily. Not a problem. Now, let's put our cut off pieces to the side. Clean up our job site for a second. Small amount of aluminum here that I don't want to have needlessly sit here. I would just use a shop vac, what I would end up using on this. All right. Now, if this, I would not discourage you from putting painter's tape or masking tape down on this when you're manipulating it. There's no reason to needlessly scratch what's going to end up becoming the client's finished hardware. Okay, so, well, at first blush, they're the same length, so that's a good start, what we've got right there. So, I'm going to turn it back around the way that I was not going to work with it in the same orientation as how we had. Okay, so now we need to install the arm bracket. And now, because we have a good length in terms of a final fitted length, I'm going to position that arm at about 4.5 inches from the end to where the screw is, because that will mimic the other side. And I don't know if that's going to be ideal or not, but we're going to find out. Yep, it's going right through there. Not a problem at all. And what I mean is, we'll find out as we're going to test our operation to see if it works for us. If we like, got that actually a little further over than I wanted it to be. That's better. Added about 5 inch. And I just want to know that that screw is at the same distance from either end, so I can observe the performance, the operation of the unit once it's installed. And I realize that this is quite painstaking, but if you're looking at this, you've never done it before, and what you're watching is the first time that someone's doing it. Okay, so the next thing, I should have put that vise away, is to cut our rod to length. That's going to be necessary. And I'm just trying to gauge here as to what sort of length I would end up cutting this to. Right. Okay, let's get our vise again. Obviously, if I was going to be doing a large quantity of these, or if I was assembling them from their raw components, or their base components, I would be paying attention as to how I could maximize my efficiency. So I have an idea of where I want to trim this rod to. I want to trim it right to about here, because when I fold it over or turn it over in the vise, it's going to end up going into that hole that's here, and that's quite frankly going to be what the concept is. So put a little pencil mark on there just so I have a point of reference. And I'll tell you, the first time you end up doing something like this is when you learn what the results were of what the decisions were that you made about how to proceed with the work, and you adjust accordingly. So I've got a small pencil mark on my rod. Yeah, and I can certainly see it. And I don't have a magnet here, but I'm quite sure this is steel. At least I believe it's steel. No problem. Yeah, I believe that must be steel. So now I'm going to put it inside of here and see if I like the length that I've cut it to. And I do. We're going to put it into the hole furthest towards the end. You can marginally see that, but I like where that's going. Alright, so now the key is going to be bending it over. And there's no clear direction as to how to best do this. But we are learning as we go along. Okay. Okay. I'm tempted to get a wrench and try to bend that by hand, but I'm not real confident. Okay, I'm not real disappointed with that at all. And if it fits reasonably well, then we'll know that we've got a good idea on our hands. Oh yeah. Yeah, just our little end of that's a little flared out, because of the cutting process, I would probably end up putting that onto a grinder real quickly to clean that off if I needed to, which I don't. Oh, yeah, I like that. I would say that my rod's about 1/16 of an inch too long, but I'm not worried about that at all. All right, let's put that down. Let's put our tools back. Leave a clean job site at all times. So, I'm quite sure of at this point, we're going to need to measure and mark our hole that will need to go into the housing to keep our unit from moving on us. So we're going to need another hole right over here where that hole is. A hole drilled and countersunk, in fact. Okay, so like I said, we've now got to drill that hole, and I did, kind of retain the original piece just to show us where that needed to be. Looked like they were drilling it just ever so slightly below that groove that's in this extrusion, and that's going to be our guide. But because the countersink is so large, it's larger than it needs to be. That hole being off a very small amount is not going to be absolutely mission critical. Yeah. Actually, what I've noticed here all that's doing is limiting it. Yeah. What I've noticed here is you do need to be mindful to not place any holes that go through the unit close to your spacer blocks or to your guide blocks. So we're going to be okay because my hole is here, but you're going to need to be mindful that when you're cutting this to not have any holes that are going to go through the workpiece to physically secure it to the door, of which there are 3 on this one, and over here, that none of those will go through that block is the bottom line. That's what I'm trying to say. All right, so basically I'm just squaring this off to the end of the workpiece and just marking a hole that I know is going to be quite in line with where we need to be. I really couldn't say that it's absolutely mission critical for that to be spot on, but just eyeballing it, I can tell that we are. So now we're going to need to drill and countersink a hole. So let's make our provisions for that to happen as well right now. Let's do that. A very small hand screw gun that I've had for many years, and it's ideal for very, very small jobs like this. see if we need to countersink this at all. Or I should say, not countersink, but center punch. And then we apparently don't. And given the fact that this is going through, I want to for sure deburr that, but I'll be countersinking it in a moment, which will take care of that. What I believe they've done is used a larger drill bit for the countersinking process because of what those countersunk holes look like. Yeah, the countersink's big enough for our screw requirements, that's to be sure. A little countersink on the other side. No real need to do that. Actually, oh, no, actually we do need to do that because this is actually our finished side out here. Because of this is going to be our end towards the hinge. So yes, this side absolutely must be countersunk. That's a right-hand reverse door that we're putting this on. Actually, no, it'll be a left hand is what it is. That's for sure plenty big enough. And all I want to do now is make the hole a little bit larger. Oh. Yep. Now, one thing that I don't have with these factory samples are good. What I don't have are fasteners to hold this onto the door. So I'm going to have to pull some of those off. Let's continue with our methodology of keeping a clean workspace. Yeah, we should not need to drill anything again. little bit bigger pieces here. We're going to use our counter brush. Okay, now the basic reassembly. Yes, so now we're turning it over because this is going to be the hinge side, and lining this up, it looks like we've got that screw in a good spot. So let's slide our unit back together. Okay. Yeah. Yeah. Okay. I like that. Now, I can see that our hole is lined up fairly well. So let's put that back in there. Then we're going to test its operation. It will be the proverbial fingers crossed moment. Yeah. I'm pretty happy with how that looks. Okay. So here we go. Does it work? Oh yeah, it works well. That works really well. Yeah. So what is the deal? Was this a success? It's coming all the way back up. I'll tell you, I would be really tempted to hold that spring and arm assembly as close to the end as possible, is what I would want to do myself. And that, the logic there is that it should be snapping it back up into place. It is, but I might draw it a 1/16 of an inch tighter. If that's what we were doing. So that would be something I'd want to do. Yeah, on a follow-up unit that I would cut down, I'm going to want to hold that much closer to the end. So I would be investigating what it would take to get that closer. Now, the factory obviously is sending out their units. Maybe that doesn't really matter. 10 3/8. Yeah, I'm at the exact same distance from the end as this factory unit is. And that's, again, 4.5 inch. I know is where we are, 4.5 inch, because that's where I put it. Yeah. Yes. I'm just comparing these two. Yeah, I would say that mine lags, draws down a little bit on the latch edge, which is not what I'd like to see. But at the end of the day, I'm going to hold that off of the floor such that it's not going to be making contact. So I'm not overly worried with that small amount. And my bar may have been a 1/16 of an inch too long. Too long. Which could account for that. Considering the fact that I'd never made one in the past, I would probably experiment with attempting to get it a 1/16 of an inch shorter. I feel like I was a little... Yeah, that does make sense. I feel like my bar was a little bit long. So, like a 1/16. So if it's a little bit long, you're already compressing this end here. So if this bar inside of here is longer than it needs to be, when it comes back up, there's still going to be extra length there that's going to contribute to this being just pushed down ever so slightly. So that would be what I would experiment with on the second run, is the bottom line. That's how I would end up experimenting again. But I'm pretty satisfied with this. The next thing is now to get some screws and go install it on that door. So let's do that right now. Okay, now we're picking this up literally at the point of installation. So we've got our door here. Our bottom should fit right in the middle here. I sure hope it does. And it does. It just doesn't because of the drop bar that's projecting out of the end of the unit. So yeah, we're in good shape there. Yeah, so let's get the door closed. Now, I need to cover about 3/8 of an inch, I would say, or about the height of this end bracket. So I'm going to position my unit basically in here, and it's going to be dropped down because of where my drop bar is. And all I'm going to do is I'm just going to go through here and I'm going to run my screws. What I would be doing is just simply measuring up from the bottom of where I need that to be and measuring it with the door in the open position. In this instance, we've got a hollow core door, so we're not going to put too much pressure on that at all. Here we go, nice and tight. And those were just 3 screws that I came up with in the back. All right, so let's see what was caught. Yeah, okay, so we're hitting over here just a tad. We're sucked back up in. We're not making contact with the floor at all. when this comes to close. And when we close the door, we're making contact with the floor all the way across. As soon as I go to open it, it gets drawn back up into its housing. Yeah, absolutely it does. Seal. Comes down and makes good contact there. Yeah, we're definitely sealed all the way along down there. No doubt about that. We have a complete seal. Plunge bar is held in, I should say, as you should be able to see. Sealed all the way across. The only thing I did, I think I left it a little bit tight here. I should have taken off probably 3/16. Would have been a better amount to take off. And when we get that door open, let's test it or look at it over here. Right about there is when you've got that unit coming back up into the housing. And right there, where the plunger is, that's when it's starting to make contact here. So, what I would want to do in this instance is I believe that I've got that drop bar sticking out too far right from the word get-go. So I'm going to turn that in about 1/3 of the way. Oh, so sorry about that. Let's take a look at what that's going to do. I'm reasonably doing it with my hand. It's for a slotted screwdriver, so that would be the tool to use. So let's turn that in. Yeah, right about there. Yeah, I got seal all the way across, and the key is I can tell that when I start to open it, I'm getting less resistance from the rubber underneath here is folded like this. And when you push the door open, that rubber has to come here and then here, which tells me I'm dragging too much on the floor. So I'm going to turn that in a little bit more and start to study the difference in behavior. Yeah, didn't make... Oh yeah, that's the ticket right there. I've got contact all the way across. I can feel it with my fingers. And when I go to open it, I have very little resistance hanging on the bottom of the door making contact. Actually, I'm going to turn that out about 1 turn. Oh yeah. Yep. I can tell that there's a little resistance because this is a hollow core door, meaning I know that I've got contact at the floor. So I can feel the door start to open and the bottom is just being dragged before it's being lifted. So I'm really... contact, and you can see it dropping. And you can see it dropping. Now it doesn't close because it's a hollow core door, and that closer that's up there doesn't do the job. But when I pull it closed with my hand, I now have got contact here. Actually, I think I'm going to want to go another half turn or so out. Yeah, we've got you set up in a good spot. You've got contact. Closer pulls it to the... Yeah. Yeah, we've got contact here. This is good. See how much closer we can get. Yeah. Watch right here. Yeah, I know it's a little blurry because of how close we are. Contact, it's pushing in, it's dropping. You can see it's dropping. Now the door gets to where it can't go any further because of the inadequate door closer. I pull it closed and you can see the balance of it drop. Okay. Now when I go to open the unit, all I'm doing is like the sweeping action is the only interference I have. A little less blurry on that. Yeah. Pretty cool how that closes all the way. And then it makes that final drop. Let's try it on the latching side. That's just a storm door closer that's on there. I apologize, but it works. Won't go any further. Right there, I've got contact. Go to open it, you'll see that it folds back. That tells me that I'm making contact with the floor. And my only error here is I would have made it a 1/16 of an inch narrower, or maybe an 1/8, put an 1/8 on either side. Now speaking of an 1/8 on either side, you'll notice my seal has a minor gap right there. You may not be able to see that, but there's about a 1/16 there. Next time, I'm going to leave the inserted gasket. If I cut the unit back 3/16 or a quarter from the stop dimension, 3/16 is going to do it. I'm only going to trim that short. I'm going to leave that long, a 1/16 of an inch for sure, so that I do have a little bit of contact here. You know, just to kiss it, just enough to make small contact. Those 3 screws I pulled out are fine. There's nothing wrong with those. That's the hole we drilled and countersunk, so that turned out really well. And this is the first time we've installed this Parker door bottom, and I would say that it was a success. Sorry about that camera being crooked. There you go. That's the installation of a Parker door bottom, and my gosh, if I made this video a second time or edited this down, this would be done in 3 minutes, tops. Keep moving. Easy money to install these. Obviously there'd be flathead screws if that came from the factory. So I'm pleased with this Parker door bottom. STC46 right there. Security as well. There's an aluminum bar inside of there. Try to force something underneath there, it's probably not going to get you very far. If this was a lever up at the top, it's a knob. If that was a lever, the bypass that people do is they'll stick a tool underneath here, bring it up, grab the lever. Then from the opposite side, they pull down, they pull that lever down to get the door open. The Parker door bottom inherently has that aluminum bar that's inside of there that works to prevent that sort of bypass. Or break-in. Bypass is the industry term for getting by a lock using a means other than the intended means to get it open. All right, thank you. Thank you for watching this part. So what did we learn about cutting down that door bottom to length? Well, getting it installed on the door, what I realized after the video stopped is that I forgot to install the end caps. So that created less space. So you're going to want to trim that unit back down 1/4 inch. And I just split the difference of 1/8 of an inch between the housing on either side. That will give you enough room to slide these caps on. But again, I would take that insert down in the bottom and I would pull that out to the point where I was then going to trim it and leave it 1/4 inch, because after installation you can get in there with a sharp type of X-Acto knife and then trim it to the exact requirements. That's what I would end up doing on that installation. Other than that, you need to make sure that you leave enough room so that the closer can still get the door closed, assuming it's a fire door. Or something of that nature, meaning a door that must always latch, obviously a fire door. As we had demonstrated, or will demonstrate, I'm not sure where in the video it is, very low closing force. So that small screen door closer got the door closed, depressed the plunger, and only stopped once the latch bolt hit the strike lip. That storm door closer is not going to overcome the force required for that strike lip, is the bottom line. But other than that, the installation went just as it should. So, let's continue on. Okay, here's our force test of the Parker door bottom. This is a 18-inch model, 24-inch, forgive me, 24-inch. So let's see how much force it takes to activate the drop bottom, which you'll be able to see right over here. So you see that there was an initial amount of force. Looks like it's about 5.5. To get that all the way dropped, I might. Let's try that again. I believe I'm taking it in just too far. Yeah, it looks like a peak was about 5.5. Yeah, that's pretty low in the sense of how much force it would take typically to drop an automatic bottom. Now we're going to take a look and see what force is required when this has been sitting in a freezer for 2 days. All right, you can turn it on. So this is the amount of force that it takes when it's been sitting in a freezer. Oh yeah, it takes more force. Looks like it's got a peak of it looks like it's got a peak of about 7.1 and all the way extended comes down just over 5, about 5. Yeah, so there is a noticeable difference, about a 20% difference. Architectural Builder Supply is pleased to present you with this recording of the technical question that is listed in the title of this video.
This call may be monitored and recorded for quality assurance.
Maybe representing the product in the US. Do you have any, I don't know whether you've had any further thoughts on it. Just to give you a bit of history, the PDB411 and the Surf ceased production back in 2019 because we kind of, my sponsor within PEMCO retired a couple of years before, and basically we couldn't come to an agreement, so we brought the actual manufacture back to the UK. So, and then of course COVID hit, so it slowed things down a wee bit. So, but we're back. We produce the product here entirely now, but it would be very helpful to get back to service some of the US customers that we had before. So that's kind of where we are at the moment.
All right. May I ask a question?
But please feel free.
So, how does the PDB 411 adjust itself to an uneven floor different than any other automatic door bottom?
Right. The way the PDB411 works is, the reason I will say, one bit I missed out, the reason we brought it back to the UK is I'm the original patent holder, so I hold the patents for this product. But the actual product itself will adjust to uneven floors within reason, because the arms inside, there are two arms within the product, as you probably know, which allow some minor adjustment. I mean, you couldn't make like half an inch of adjustment, but certainly there will be some minor adjustment for an uneven floor. Only so much as the difference with the PDB and traditional drop seals is we don't have a kind of bubble rubber seal at the bottom of the product. We have an aluminium bar, which actually is the bit that touches the threshold. And it's pressured down, so it's under pressure. So unlike a lot of seals, yes, you can press them down, but if you've got rubber there, rubber only has, a particular sound quality or sound reduction and ability to last, whereas the aluminium bar will provide a lot more USPs than the rubber seal will.
I see that it appears to me, though, it drops down evenly as the drop bar gets pushed in when the door closes. And do you find that there's any problem in the lock style making premature contact with the floor while the door is not completely closed?
No.
Okay.
Do you remember the PDB411 before, when it was issued by PEMCO?
Yeah, sure.
I think you did sell it, didn't you, at one stage?
Yeah, I did. But I don't recall if it dropped in the same fashion.
Yeah, it drops evenly right across the whole threshold. The PDB411 previously did exactly the same thing.
Right.
It just drops evenly. So immediately the door closes, bang, the seal comes down. There's no drag on it at all. So the contact is pretty quick and immediate. Whereas I think with other drop seals, the lock side drops, and then the hinge side drops, and then the lock side drops. But there's no, but they both drop in the PDB. It drops evenly.
Which can certainly be considered an advantage. How much of in the sense that if you have a problem where your gap is greater at the hinge side of the door. How much of out of level flooring? How much out of a level flooring condition will this tolerate? 3/16 maybe.
Yeah, right. The flexible arms inside the unit. Well, I mean, it's quite easy to take one apart. Actually, there's a screw about 2/3 of the way down the seal. What you can do is undo the screw. It's just an ordinary Phillips head screw. Just take it out, and you can pull the mechanism out really easily. But what you'll see is the drop bar, the actual the arms that control the drop bar. They're made up of 5 sections. 3 which are polypropylene, which is hard plastic, and then there's 2 elbows there, which are like a TPE or a flexible rubber. Mm-hmm. So effectively, if, for example, then the seal would come down, it would continue to go down on the far side. So that flexibility, yeah, I think, to be honest, if your floor was too far out, as you can appreciate, I don't think many seals are going to handle that anyway. But I think you're probably 3/16 is probably reasonable. Yeah, I would have thought.
Yeah. No, you're right. If you've got that sort of major problem, then automatic door bottom's not an answer. And you do. You find that with extremely, especially with poor construction in, here in Florida, you'll see a lot of buildings that are put up as cheaply as possible. I'm used to things being commercial grade and then standard duty and then low end. Well, there's a couple of tiers below low end that you only see sometimes only in Florida for me. Really shoddy. For an example of that would be when you run line voltage in a residential application. You don't need to have your wires in conduit, like where I lived in Chicago. That's per code. That's all got to be in conduit. So I think to myself, well, be careful where you drive a nail into the wall if you're going to hang a picture. So I mean, what impresses me about this automatic door bottom is its fit and finish. It doesn't seem to be something that people would really think about, but given the quantity of them that I've seen, this presents very well when the client removes it and holds it. And to me, that means a lot because it tells me a lot about, the control over the manufacturing process. If it looks good by the time I get it, there's something right happening. So from the entire product line, is this mortise style 411 what you have, or are there other items?
Right. My background is acoustics, so I'm an acoustician in the UK, and I've worked not around the world, but I've certainly worked in Europe and in USA and in UK on various acoustic products of many different kinds. And I think the thing with you have with the door, obviously you have 4 sides to the door, so the automatic door bottom, the mortised version, by far, that gap at the bottom of the door is by far the biggest challenge to try and seal, as you know. It is a real engineering challenge to actually closes off that gap successfully for a whole range of reasons: acoustics, fire, security. I mean, security is a big thing as well. PDB gives, which no other seal does. They can't lift the PDB locked in place, and stability and all the rest of it. But we have a range of the Jarman head seal. It's very similar to PEMCO, to be fair, because the PEMCO style of Jarman seals, they're economic, number one. Number two, they are fairly efficient, up to probably late 40s STC. And if they're positioned correctly, and also they're cheap to replace, which is a good thing, and they don't look too bad. I think that's the other aspect. Architects, I think, don't shy away from them too much. We have an expensive option, which is a replacement for the doorstop, but I don't think that would be any use to you in the US because your door frames are typically steel, aren't they? In the main, formed steel. for a lot of applications anyway. There are very few where you have a timber doorstop or a timber frame as a standard feature. So with the PDB411, we have the PDB4. That's the 411M. We have the PDB411S, which is the surface-mounted one. So you remember, which is either semi-mortised or surface-mounted. That actually fits on the outside, exactly the same product, but it's all part of our line. So the reason why we stuck with kind of one seal application is because I did a lot of research on this, and if you look at companies like Athma, who are a German company, they have 88 versions of their drop seal, all doing the same job. If you look at North Seal, they probably have 30. Lorient are probably 30 to 35 drop seals, all doing the same job. Pemco probably have 20 or 30 doing exactly the same job. And to mention NGP, probably, I don't know how many, I've never counted NGPs, but so we've tried to have it as a one seal fits all. So it will operate from the lower STC range right up to the highest STC range that you'll practically require, probably in excess of STC 48. So it's the one seal does the job. It may not be acceptable in commercial retail terms, but that's what we try to target, because I looked at all the variables in all the other seals, and to be honest, it's a little bit, as a colleague of mine used to say in the UK, it's a bit of smoke and mirrors, really. Pemco just reissued the 434 as a heavy-duty seal, which, when you fit it, it takes away quite a lot at the bottom of the door, but it doesn't perform anywhere near as good as the PDB411. And I take lead from this because Phil Goosens, I don't know if did you ever know Phil Goosens at all?
No.
No. Well, Phil was he was the president of Pemco for 20 odd years, and very experienced person in the whole field of acoustics, and particularly drop seals. And he, in the end, his preference was the PDB411, and he sponsored it within the Pemco systems. But he retired in 2017, I think it was. But I was guided by him because he was in the US market, and he developed a lot of the Pemco seals prior to that, and the PDB basically did the one job. So to answer your question, I'm sorry I've rabbited on a bit, but to answer your question, it is one product, which, there are two products, obviously, the surface mounted, or semi-mortised, and the mortised. One little side issue, one advantage that we've had as well is PDB. We use it in mental health settings in the UK as well, where we can actually put the button on the lock side of the door, and we have a plate, a bit like a guide plate, which enables the seal to close with the button on the lock side, not on the hinge side. So, it shows the flexibility of the system, really.
Well, you know what? That solves the problem a little bit better as well. When if you have dealing with uneven door gaps, that can help solve that as well, in the sense that if you had a really tight margin on your hinge, and it sloped away towards the lock style, it's hard to get that door. Someone will say, pushing the door closed really hard, but if you don't start dropping until your latch is basically engaging the strike, that's neat. What's the shape of that? Is it just a triangular type of bolt? Is it a Pullman style latch?
No, it's all it is. Literally, it's exactly the same as the PDB411M you have in your hand, or on your desk.
Yeah.
All you do is reverse it.
Yeah. Button
on the hinge side. On the lock side. Getting confused now. And we have quite a small plate, which actually is a guide plate, which can be recessed into the frame, And that guide plate then does exactly the same job with the button as if it was on the hinge side.
Oh, interesting.
So, and it closes perfectly. Now, if you have a double swing door, which is the reason it was developed is because on a mental health setting, in the UK, and I think it's the same in the US as well, you have to have the ability to open it. You have a double swing door.
Yeah.
You have the ability to open the door inwards as well as outwards if the patient jams themselves behind the door, kind of thing. So that was why it was developed for that particular application. But you're quite right; it could be used if you do have a bit of a fairly uneven threshold.
And yeah, we would certainly call that rescue hardware. The other area that makes a lot of sense, you've mentioned, a double acting opening, is in California. It's really popular, but you'll have a 5-foot wide door that's center hung. So they'll toss some ricks and pivots onto there, like a 370 or something, and they want it to be sealed. Well, the problem with the mortise, if you in a typical door thickness, is you're not going to be able to fit that. You could very possibly use a semi-mortise and solve that problem. Yep. Or I'm doing a job now where the client's got a 3-inch thick door, and they're going to put a Fitzgerald's pivot system on there, which I'm just simply trying to convert them to something a third of the cost and does the job just as well. The point being is I'll be able to stuff an automatic door bottom down there to solve that problem in this case. Mm-hmm. The only thing that I would say is obviously Zero for us is the big name when it comes to the high end or the higher STCs. And they have a model that has an attaching flange only on one side of the body, and that if we were to take this 411 and rip off one of the aluminum flanges, that allows us to potentially get it installed or stuff it into a very confined space. But that semi-mortise would certainly work,
Yeah.
So that's really fascinating because that solves that problem. At least I believe it would. And I see that it's UL listed, so we don't. You're going to bump into that, obviously. Semi-mortise UL listed for hotel rooms. You've got to have it for ADA. You've got to have it for fire rating. You can't have that.
I mean, we've done UL testing in Germany, and we have a standard in Europe called the BSEN 1634, and that's a very harsh standard, very, very harsh. It's harsher than UL actually, but the drop seal comfortably sat there for 60 minutes plus, without any difficulties whatsoever. We didn't take it beyond that, but my personal view, I don't know if you share that view, but I think if you've got a door that lasts 60 minutes, if you're not out to sleep within that time, you won't be in good shape. So I think 60 minutes is quite acceptable. The theory is it could go to 82 minutes, but we haven't tested it that far.
Yeah, sitting in codes class, why is it 90? Why is there a 90-minute door? Well, you've got 300 yards that you've got to travel, and you're doing it on, your hands and knees, and it's pitch black out. So, but you're right. I mean, I've never seen any data, that talks about that additional 30 to 90, let's say, minutes actually saving lives. I wouldn't be the first person that would see that to begin with, but
I think as well is there's a lot of one thing that's been the consultants here in the UK, what they're and they're trying to push it with the UK government as well, is what they come to is most of the smoke. So if you have a fire in a bedroom, for example, most of the smoke emanates or comes out via the bottom of the door.
Yep.
And PDB, and I guess to be fair to competitor seals as well, the PDB joins the competitors in so much as it seals off that gap, such that you're able to see within the corridor, so you can see where you're going. But the other big advantage, I think, of the PDB as well, if a fire, say for example, is in the corridor, and you're in the bedroom, you won't die from flame. You will die from asphyxiation in the main, because the fire sucks all the oxygen out of the room, out of the bedroom, into the corridors to service itself.
Yeah.
So these seals do have a practical, useful application in saving lives if they're fitted correctly and they operate correctly in the field.
Yeah, right on. Have you done any cycle testing on this, in the sense of, I've been to Bomber's factory. They're the oldest, although they'll be ceasing operations. They're the oldest American manufacturer of hinges. And I've been in their engineering area, and they're cycle testing their products, and it's really fun to just watch that solenoid move the hinge leaf over and over again. Yeah. Is there any cycle testing that's been done on this? We'd obviously call it grade 1, 2, or 3 kind of stuff.
Yes, we've done it to 1.1 million cycles, and the reason for 1.1 million cycles is the motor operates and the solenoid itself burnt out. So we decided to give it a miss at 1.1. We thought that was enough. Yeah, absolutely.
It's grade 1, 1 million cycles. Well, it doesn't break on the million and first operation cycle.
Yeah.
It could go 10 million cycles. I tell people that's just where they pulled the plug from the wall. Is there how many pounds of force would be very low closing force? I ask that because I can easily do it with my finger, and that is atypical. And I'll add on to that by saying that when it retracts back up, in 30 years, I've had the complaint twice, and I never thought about it, but it's relatively quieter when the door opens.
Yeah. Yeah. I mean, the closing force, I be honest, I don't have any data on that, but what I do have data, the pressure, the downward pressure on the drop seal is about 12 pounds a square inch.
Yeah. I'm going to say that the closing force is probably easily tameable by the use of a handicap compliant door closer, which is really important. We've got to have reduced opening force. Well, with a reduced opening force comes a reduced closing force, and this seems I do have a force gauge somewhere in my doctor's bag, but this seems really low. I would think an ADA compliant closer would have no trouble working getting that door closed with this model. So, okay.
I think it as well. So, because fundamentally the way it operates is when button that puts pressure on the first arm, and there's a spring. There's two springs inside. One for the first arm, which actually has no other function than to tip the arm downwards, and that arm has a rod which goes from arm 1 to arm 2. And that obviously then the force is then directed downward, because both arms then take control of the way it works, and of course you get this quite high downward pressure. The other thing you mentioned, the 5-foot door, is that this can happily be used 6 or 8 feet wide doors if needed. So it can be you can kind of daisy chain if that's the correct term to use, but you can daisy chain the mechanism inside. So it's quite helpful, it's quite robust in that way.
Are you saying that you can install these in series, so to speak, to use an electrical analogy?
No, the way you do it, you'd have, say for example, your door was 6 foot wide, 72 inch, have a 72 inch casing, and inside the PDB, you'd have 4 arms. You'd have 2 and a 2. So basically, they'd operate in exactly the same way. So your actuator button would be pressed in, and right the way along, it would actuate the drop bar in exactly the same way.
Got it.
That's a massive advantage, because a lot of other manufacturers have to I mean, for example, Pemco tried to replace the PDB with another model called the STC411. And all they actually did was increase the strength and tension of the spring. They did nothing else. They just did that. But what that did, it has the reverse effect, because it gives you your low closing force disappears, because if you try pressing one of those in, you'll bend your finger backwards. They're very, very powerful, which, you know, as you say in ADA terms, it's probably not the best. But you can't then lengthen it. You can't if you have an odd application. I mean, for example, in Europe, we've been working with 4 foot 6 long seals quite successfully with 3 arms in, work perfectly. And in fact, within reason, the longer they get, the closing forces remains low, which I think is a real benefit. And all the same performance aspects of the seal remain intact. So you don't get a loss whereby the end lifts, or you don't get the pressure at the far end that you want, and at the same at the button end, you get the equal pressure right across the whole bar. Almost. I don't know the technical length we could go to. I know.
Yeah, there aren't many 12-foot swinging doors.
Exactly. Yeah.
Yeah, this is a. I don't disagree with keeping it simple in terms of, you're right. There a lot of these manufacturers are doing the same thing over and over again, and it's either mortised or surface mounted, and it's almost always surface mounted. Yeah. What finishes are available on the surface mount? Is it clear and dark browns, I imagine?
Right. With the surface mounted one, I kind of, and this is me speaking now, I kind of didn't like the look of the screw heads. Right. So we've made a modification to it, which I can ping you over some drawings to show you, where we have a slide-on cover. So it doesn't rely on any more screws. The seal fits exactly the same. So you screw it in. And don't forget, the PDB is the only one you can screw through the mechanism. So you can actually screw through the mechanism itself, where you can't do that on any other seal. So you reduce the profile height of the seal, because surface-mounted ones are, if you're not careful, they can. I won't say ugly is the wrong word, but they can look intrusive, can't they?
Especially, you're right. I love Zero. They've got a nice product line, but their material is. I've had people tell me, "Wow, that thing is huge. I don't want to install that on my door." Yeah, they're thick. They're thick.
Yeah. Did I send you a surface mounted over? I think I did. I can't remember now, but
you did. I can easily one in here. Absolutely.
Yeah.
I didn't pull them all out. Oh yes. I only pulled out the mortise that was here. Yeah, I see. Yes. Okay.
So the surface mount got a very low profile.
Very low.
What we've done is we've adapted it so that we've got a slide-on cover, which is a plastic cover, which can be another sale item for you, but it can be any color you want it to be, because it's plastic. So you can have any color you like from whatever, any RAL color. Do you call them RAL colors in the US?
Well, I'm familiar with that term. I mean, someone will specify an RAL color, Tectus, that's very common to see it, and that can a concealed hinge, and they're specifying colors. But yeah, I mean, we've done hardware where someone's asked for that, or steel vision frames for use indoors. You can specify, RAL colors for that. Yeah, this is 7/16 thick. That is really small. Really small. What do you do about it?
Sorry?
I'm sorry, Brian. Go ahead.
No, you're going to ask a question, Richard. Sorry.
Yeah, no, the cover on the. I just had a client who ordered Reese automatic door bottoms, another company that I like a lot because of how nimble they are. But they do not supply caps for the hinge edge, although you can buy blank caps separately. What is your approach regarding the end of that unit on the hinge side?
There's some end caps supplied with both seals. There should be stainless steel end caps, which kind of crimp on. But what we've just done a redesign on those because I'm on improving on giving a seal which actually gives the same acoustic performance in the field as it does in the lab. So we're having a different type of end plate which will actually clip on to the end of the bar itself. And so when the bar drops, the end plate moves up and down with the bar. So
wow.
The end caps we've supplied will fill the gap, so to speak. The new end caps will be available probably in September, October time this year.
Right on.
And they'll just be you literally can just push them on. And you can have things like, for example, if you wanted to put a pad on them to improve your acoustics, because as you know yourself, when you do these acoustic tests, there's a little tiny gap
Always
on
a
the
gap.
right-hand, left-hand side of every test door, and it's ever so difficult to get rid to fill that gap. Our new seal end plate will deal with that.
Yeah, always a gap. You know, those dust plugs are what we call those.
Yes.
Always a gap. Yeah. So tell me, how does the slide cover work on the surface mount? I'm not understanding how that would work.
Right. If you look at the surface-mounted one now, what we've done, we've added on the top of the core, you've got like a flat and a little bulge and another flat. Well, we've actually just made a minor extension of about 5 millimeters, so almost like a claw feature on top of it. And again, I can show you drawings over so you can have a look at it. But then the plastic plate just slides straight on from the side, so it's really, really, really neat. It makes it 5 millimeters deeper than what it is right now, but that's it is small anyway, and it doesn't make it significantly taller such that people would object to that look. And it's the best way of doing it because that then hides all the ugly screws that are used to position.
You still there, Brian?
Yes, I'm still. Yeah, I'm
okay. The phone dropped out for me. And with the double. Okay. Yeah, I will. I'm typing an email as we're talking, so I can send you. Here's what we discussed. You know, the couple of things.
Okay.
Yeah, that's neat. So where does the material ship out of? Is it coming out of the UK?
Well, at the moment, it will come out of the UK. But again, we were looking at a company in San Diego to work with to have a kind of a base in the UK, in the US. But so I'll be honest with you, we're still working on that. But again, I don't really see. I mean, we can get product over reasonably quickly to the US. There's two ways of doing it really: send the entire product or send the product such that it's in two parts, so it can be assembled there.
Yeah.
But we're working on that at the moment. So whether you had any suggestions, that might be helpful. But that's where we are at the moment.
Yeah, I'm a lot of that stuff. I've seen a lot of that stuff seems to work initially, but fail long term. And having a robust, having a reasonably robust distribution base that actually keeps material on the shelf is the ultimate goal. Is the ultimate goal.
That's what we'd like to towards, without a doubt, because I've worked in the US as well, and the same comments come back. People want fairly easy access to the product, and I have a number of irons in the fire at the moment, which are just bubbling away. But hopefully, we'll have something certainly of a concrete type or concrete format certainly by September, October time this year.
What do you think a distributor should keep on their shelf? Let's to speak specifically. you are obviously familiar with the demand that's coming from over here. What if I put X quantity of material on the shelf, and you say, and inquiries could, until your approach to getting an installed distribution base continues to evolve, we could, for the next 6 or 12 months, you could have a guy here, me, who has the ability to fill an order of 1 for 20. What would be the type of quantities and the idea of initial investment if I were to say, yeah, Brian's not going to stop doing this, so, you're going to buy his door bottom, damn it, eventually. How many would I put on the shelf?
Well, that's down to you, I guess, to some degree. I mean, because what your order profile is, and I could look at the profile of the orders that we've had in the past, speak to people, and it would be fantastic to have a base. And I think in terms of we probably initially supply, say, 1,000 units initially at our expense, and then we could get a rolling deal going. So that would give you a bit of, because obviously you don't want to be putting stuff on your shelf for nothing. It's got to be to your advantage. But there's advantages to us as well to have the distribution point in the US.
Yeah, they're here. Exactly. They're here, and we dozens of packages a day get sent out of here. It's just pull it off the shelf, pack it, and ship it. I've got 2 people. That's almost all they do. And there's a kind of an advantage, which is a little hidden one for the PDB as well. You can relatively easily custom size it, and if the real thing that creates the differences in a PDB is that there's an internal rod, which is the transfer rod, and that transfer rod, if you take it out and put a different size one in, you can adjust it up and down on the bar and chop the end off, and you can really do a lot of flexibility, whereas a lot of other seals have a fixed length spring in them, and you really can't adjust them significantly. There's an adjustment at the end, of course. Most of them have about 4 inches, don't they? But typically. But the PDB does have this flexibility. But we'd have to work with you, I guess. And you say to me, Brian, 36, 33, 30, and we could break up, a package which would work within those lengths. Each one will be able to go down by 4 inches, 4.
And see how we.
Yeah, that was the question in my head, and I'll tell you. So you're saying that you could make a 30-inch, which always has to be cut down if it's a surface mount, and you can trim that by 4-inch.
Yeah.
Okay. Because a 30-inch is useless. 36 is useless. We're push side mounting. I don't know why we even stock them 36. I mean, obviously we have to stock them at something, but 35 is a better, 35 and 11/16 is a better guess than 34 and 11/16 is a better guess than 36 in lots of instances. Where are you located? I mean, I know generally, but where specifically?
Well, we're located on a place called Hayling Island, which is on the south coast of England, next to a city called Portsmouth. I don't know if you're familiar with Portsmouth or not. It's between the city of Portsmouth and the city of Brighton. We're sort of located there, which is about 67 miles south of London. South. So, but our manufacturing base is near Bournemouth, which is further west along the coast. We have a partner factory there, and we can pretty well throw out as many as, and they've got a distribution network as well, so we can get all the stuff to you. Give us a couple of weeks and whatever, but we'll be able to bash them out for you, no problem.
Yeah, is that I mean, the only Portsmouth I'm familiar with is the one in New Hampshire. Probably the second one. Is that Isle of Wight, the one that I would know from Beatles songs?
Oh yes, it is. Well, my property is opposite to the Isle of Wight, so I can see the Isle of Wight from my my bedroom windows. So that's how close we are. So, but it's where the manufacturing base is near Bournemouth anyway, which is which is further west, and they have good. There's a good link from there to the various motorways to get it to distribution points. So we don't have any issues that way.
What would you think about the idea of me coming there and spending an afternoon with you and not only intimately understanding the anatomy of the unit, but also discussing and probably concluding how many I should put on my shelf here?
Absolutely. If you would wish to do that, I could arrange that. Give us a couple of weeks' notice, because I'll have to make sure the guys at the factory are available.
Oh yeah.
Because obviously you need to go down there, and we can sort you out. But yeah, that'd be excellent. Yeah, whenever you feel like a trip to the UK, I'll be very. It'd be lovely to see you anyway. Yeah,
I've never been there before, and there's, when I go. You start to realize when you go places you can't do it all in one trip, whether it be San Diego you mentioned, or Seattle, or New York, or any large place. And what works best for me is shorter trips, and there's things that I want to see there. My wife is Greek, and there is so much Greek history in the I don't know if it's called the Natural Museum or whatever it is titled properly. Yeah. So there's things I could do.
Yeah, we could collect you from Heathrow and take you down to the factory. So that wouldn't be a problem. You wouldn't get lost in the traffic or anything like that. We'd arrange all of that. And you can depot and drop you back in London, and you could go and enjoy the sights. Absolutely, no problem at all. Be happy, Richard. That'd be really nice.
Yeah, because it does seem to me that there's an opportunity that if we could put, an adequate initial amount of inventory on the shelf, you can say, hey, listen, we're continuing to expand. Right now, you need products shipped, and what we've got on our shelf. We could easily share that data electronically so that you could be able to see our back end of what we've sold and what we've got, and et cetera. So I think there's something to that. And I've been doing so much traveling lately. You get into a routine of it not being that much of an inconvenience. I've traveled enough this year to circumnavigate the globe, which may not be a lot for some people, but for me it is. I mean, I've gone that many miles this year. So I need to look at my September, and I don't want to come. I know I've got to be up in Chicago and then in Illinois in mid-October. So I have to check the last the last week of September. So with your permission, I have to talk to my wife to say, hey, listen, what does your calendar look like? And I would absolutely do it. Absolutely. The only downside of where I live, moving from Chicago here in Naples, is there's no direct flight. At least there's not one I'm aware of. Maybe I'll drive to Miami or Fort Lauderdale if there's a direct flight. Yeah. So I'm going to send you an email, just a couple of things that I would like to see, and namely, it's going to be show me more about the slide cover for the surface mount, and then the doodad to make the typical model work seamlessly in your double acting doors. And I'm going to check my data, and I'm going to send you an email over the weekend and look at that. There are so many things in England that I'm a fan of that you don't have to twist my arm hard to do a work pleasure trip to England, that's for sure. I just finished the Beatles Get Back documentary, and I don't know if you've seen it or if you're even a Beatles fan. How could you not be? Who's not?
I remember once when I was a very, very, very young. The Beatles were they played at a local venue in Liverpool where I lived, and we all skipped off school to go and see them. I would have. So familiar with them and a lot of their compatriots, the Hollies and Jerry and the Pacemakers, all those guys. Oh yeah. But it's the unfortunate thing is the cavern in Liverpool is not the original cavern.
Yeah.
It was the original cavern. They did a demolition and reconstruction of that area, and when they what we didn't realise is underneath the cavern was a void. So, and when they opened it up, the building up to start the detailing with the construction work, they found it was full of water. There's a great huge cavern underneath where they used to store materials and what have you. But then they moved the cavern to probably about 3 or 4 dells down from what it was originally. So, but you know, that's where the cavern was, where the Beatles were, and where everybody developed their musical presentation. So, yeah. But as you say, who couldn't be a Beatle fan? Nobody.
Yeah, at that stage of their career, you know, from what I know, they were growing apart, but not intentionally. And
no.
You watch all of these hours, a couple of dozen hours of footage, which a lot of it is, these guys just goofed off a lot. They did. They were not very productive, but you could tell that they were friends. They were like brothers, where they could get angry with each other just like brothers would. But in the culmination of the entire documentary, when they start the rooftop concert, when they are up there, and Paul and George has already got his guitar on, and John puts his guitar on, Ringo's sitting there, and they initially start playing, these guys, you could tell, loved not only playing with each other, but genuinely liked each other, I believe. Absolutely. Just, Paul he was like an 8-year-old on Christmas morning. He was just, the first few chords that they were playing was just amazing.
Yeah. And you listen to their music, actually. I mean, I don't really like the Rolling Stones and all. I kind of like the Rolling Stones a bit, but their music was unsophisticated. The Beatles' music was actually, if you drill down into it, it's quite sophisticated, actually. And it was a break from what was happening around that period. And you know, a lot of their tunes laid the foundation for a lot of what's come since. Bloke was Ringo Starr, wasn't he? He was, I think Pete Best was the original drummer with the Beatles, and for some reason they fell out, and Ringo jumped into the seat, and what a lucky man he was, just at the right time. So there's where we are.
Yeah, anyway, so if you've not seen it, you know, I would watch it. It's kind of like another, you know, English or British reference, you know, the Lord of the Rings, the Two Towers, you know, there's a part, like a third of the book is just the two of them on a death march. So the first, you know, 75% of the documentary is a bit of a death march because it's a lot of goofing off, a heavy amount of smoking, which, you know, you've got to take it in context. It was quite normal. Today, we wouldn't really, you know, see on television everyone smoked back then. But, you know, I was introduced to the Beatles by my father. I was maybe 7 or 8, 1977 or so. I was into a band, and my dad said, well, if you like these guys, you're going to love these guys. And he hands me 2 Beatles records, and it was, I didn't listen to anything till 1980. You know, Van Halen came on the scene, and I didn't listen to anything but those 2 Beatles records, the 2 double albums where they're standing inside of the building looking down on whatever floor it is, the blue and the red cover. That's all I listen to. Anyway, so I'm going to send you an email, and I'm already I'm aware that American flies direct from Miami, and that's only about, it's certainly less than 2 hours for me to get over to Miami to the airport. So, in all seriousness, put some actual thought into that early next week. I would look at the last week of September. I would think the weather is still reasonable there. And I'll send you an email now, and then a follow-up email early next week to say, hey, I'm thumbs up if you're thumbs up, and we'll go from there. I've got a very close friend of ours who spends a lot of time there, so I'm very comfortable going, you know, to another country because of the people around my relations that spend a lot of time there. So awesome.
You know, England is very safe, and particularly London. London's used to a lot of visitors as well. And the tube system is very easy to navigate. And I can show you, again, we can show you we can get an automatic card for you for going around. So it's a really safe system, and everybody, generally speaking, is very helpful. So I think within the confines of what you want to do, or maybe 1 or 2 days or 3 days or whatever, you'll see a lot, and you'll thoroughly enjoy it.
Absolutely. I've deeply appreciated you taking your time, certainly on a day off, and I've benefited from it greatly, and I look forward to continuing this conversation early next week.
Thank you so much, Richard, and thank you very much for your time as well.
Thank you, sir.
Just one final question. What kind of numbers do you normally sell with Drop Seal on an annual basis?
Oh, I don't know, but I probably have 100 in stock at any one time. I'm a distributor for all the big names here, which would be, of course, PEMCO, National Guard, Zero, obviously. I like Reese a lot because they're very no-nonsense. Sometimes when you're buying a piece of hardware, you're not buying the door bottom, because you can buy that from anyone. You're buying the relationship. In Reese, they're in Minnesota. They're simple, no-nonsense. And then, of course, the fellas, Legacy, who is at the opposite end of that spectrum of simple and no-nonsense. They're great fellows, but it's a lot of work to get an order shipped. My family's been buying from Dorbin, a regional manufacturer in the Chicago area since the 1930s. So I've got, I don't have a direct way to answer that question without looking at my sales for all of those manufacturers, but I need to stock at least that many at all times. But that sort of volume is only based on the customers that are organically coming to me, which is not very healthy because there are always people willing to work on a slimmer margin. And then also, our site isn't mobile compliant, and we are now in the latter stages of completing mobile compliance, which will effectively make it easier for the other 50% of the internet user to access our site. So next year will be a different answer, but I'm thinking of it. I probably stock 100 Zero alone, and then and PEMCO is the big name, as you obviously know. So there's enough volume there for me to stock all that stuff. Being able to justify stocking your product for my organic sales is, hey, you have a problem. Hey, here's how I solve it. Here's the best way to solve it, because we're advocates of the owner, right? We're here to make money, but we are advocates of the owner. We have to be. That's the proper way. And advocating on the owner in the owner's best interest is to be able to solve that. What I like about your product is I see that it is quiet, it is petite, it's elegant. It seems to be extremely well made, and that's where me coming there. I want to dissect one with you, or have you dissect one and teach me all about how that works, because it makes me a better salesman, and that's how I justify flying internationally, because I need to be the best salesman as possible. I had no, when it comes to international standards, EN 1634, you may have said, I'm ignorant as to what that is in the sense of, well, okay, you're telling me it's like a UL, burn test. Okay, I know what that is.
But PSBN 1634,
Yeah, but being able to, it allows me to justify coming there, because I'm smitten with the product. I didn't remove it until our phone call, from the package until our phone call started, and I was immediately smitten with the build quality of it. Stuff shows up to us as if it's been dragged behind a pickup truck on a gravel road. Especially if it, and Hager as well. Obviously, my family's been selling Hager forever, but they're almost a non-issue for us in terms of stocking any weather stripping. But Hager has such a huge footprint, and it's only growing. They have a good specifications department, and I know the guy, my mentor in the electrical hardware part of what we do, and then his name is Kevin Tish, and then Brian, I forget Brian's last name, but these are guys that are
leaders in our industry when it comes to education. So Hager does a great job with industry participation, educating all of us here. Yeah. So
because it's
anyway,
all about spec writing in the U.S. It's
all about that, and that's where Hager's got it figured out. It's all about that. Yeah. Yeah. You know, but we don't get into that because people call and say, you know, with COVID, I work a lot more from home than I ever did, and I don't want to go out there and tell my wife to turn the TV off. I want her to be able to do her thing, but I need to work. So what can you tell me? And then I've got a great guy, a customer of mine in San Diego, and all he does is sound isolation for people. He buys a boatload. He's one of my biggest Pemco customers, and he is going to love this product. He is going to love it. And I'm going to get this. One of these samples is going to go to him straight away, just so I can get it in his hands, because he respects my opinion. He makes his own decisions, but he respects my contributing to him being able to facilitate the best solutions for his client base. So I'm going to get the Surface on his hands because I think he can use it. Yeah.
That's good. So, okay, well, we'll communicate further, and thank you once again so much for your time. I really appreciate it, and it was hopefully we can move forward.
All right, sir. I'll talk to you next week, and thank you. Have a good weekend.
And you too, Richard. Thank you so much.
Yes, sir. Bye.
Bye. And just let you know, I did say I'd get stuff back to you by close of play Thursday, but it's been a bit hectic. So I'm working on your stuff over the weekend, and I'll give you a breakdown of where we're at on Monday, if that's okay with you.
Oh, it's very much okay. I'm going to be up in Tampa. DHI is having a week-long class. I'm doing advanced door frame and hardware detailing. You're not, unless you call me, unless we talk on the phone about lunchtime, which is noon Eastern. I'm definitely going to be sitting in class all next week. Or a week from today, I'll be back here at work.
Okay, that's good. So what I'll do, there's quite a list, and I'll work my way through it. I've got Darryl. I've told Darryl to get moving with those open-sided drop seals for you, and we get all. Anyway, I'll work through your list, and then midweek I'll let you know then where we're at and what kind of timescale you can expect things to be sent over.
Yeah, awesome.
Great stuff. So it's good. So did you manage to get anywhere in London when you were over, or did you go to your main workplace? Yeah. Oh, good.
Yeah. So Sunday. No, I think Saturday. No, it was definitely Sunday. The Sunday before I came back, I got up to the British Museum, and I can't say that I'm an expert on lots of museums, but I have to imagine that the caliber of what's there is literally the pinnacle of museums.
Pretty good stuff.
I just was, pretty good stuff. The Greek, the Roman, the Egyptian, just, yeah.
It's amazing, isn't it? It's a beautiful museum. Yep. I'm glad you found something that rounded your trip off. Anyway, that's the important thing. Did you manage to walk across Westminster Bridge and see the House of Parliament and all that, or did you just jump a tube?
I got across that at least twice. On Sunday, I got north of the river to the British Museum, and as I'm walking north, today's the London Marathon. Okay, cool, that's fun. So, long story short, I get trapped on the north side of the river, and I had to hike 5 miles to get around the marathon route. I had to go far to the west to be able to get around it, because there was no way to get across. There was no way. So that was, and I'm asking some guy there, I'm like, when is this going to be done? He's like, I don't know, man, 7 o'clock? And it was like 1 in the afternoon. So that was crazy. You know, it took, you know, I went, it was great. But the atmosphere of the marathon was electric. Absolutely. I mean, it's not blue collar and working class like the Chicago Marathon that I've been around. This was people running in Spider-Man costumes, you know, so.
Yeah. We are nuts in this country. We really are. You can see from the state of our political system, we're crazy here, you know. Oh, God. Yeah. I'm glad you. Anyway, that was really good.
Yeah, it was absolutely.
Oh, good. Okay, well, enjoy your tutorial next week, and perhaps best thing does it work for you if I maybe give you a call next Saturday, or what's best for you?
Right now, I'm in the middle of making a video on multi-lock high-security cylinders, and when you call me at this time, a week from today, I'm literally going to be sitting here at my desk. So,
okay.
So you absolutely call me. If you don't get me, that's only because my cousin rebuilds muscle cars, and he specializes in, well, it's not only American muscle, but my 69 Skylark, my 69 Buick Skylark is done. It's taken over a year and a half, and it is arriving down here from Iowa next week. So if you don't get me, it's because I'm unloading a fully restored 1969 Skylark, and I'll send you pictures of it.
Fantastic. I look forward to that. Forward to that. That's, you saw a few of what we've got, or what some guys have got down here. But that's phenomenal. I love the American cars when they're rebuilt. They're fantastic. They're just another level.
Yeah, it's like industrial engineering at its highest form of elegance. The 1960s colors were just beautiful, and GM made the Skylark, I think, in 3 or 4 shades of blue, and it's actually the very first car that I remember as a child, when I was 3 or 4 years old, or whatever, 4 or 5 years old. That's the family car, the Buick Skylark. So to me, it's got tremendous fond memories. Not huge like a Lincoln, but when you're 5 years old, it seemed like an ocean of space in the back seat. Big bench seats, front and back. Yeah, so I'll send that to you.
I was going to say the bench seats. I remember those. Wow, they were something else when you get 3 of you in the front those days. Completely illegal now.
Yeah,
but,
and no seatbelts.
Yeah, that's for sure. Good. Okay, well, I'll let you go, Richard, and we'll speak next week. But I'll get as much stuff as I can over in terms of paper form next week, and let you know when all the hardware is likely to arrive.
Awesome. We'll pick it up then.
Okay. Thanks, Richard. Have a good weekend.
Yes, sir.
Take care.
Same to you, sir. Bye-bye.
Top, so it'll be slightly deeper by about 1/4 inch. And what we've created is a channel. So if you refer to the drawing, hopefully I sent you over. If not, I'll resend it. And the idea is this: the cover has a mechanism at the top which enables it to slide onto the drop seal. So the idea being that it doesn't matter which side, whether it's non-sided as usual, so it can work on either side of the seal. So somebody else, wants the button on the hinge side, or the hinges are on the wrong side, and they don't have to. Obviously, they can just swing the seal around and position the button on the hinge side, whichever way the door's hung, and the seal, the actual cover, will follow that routine. And the cover slides on, and we can in terms of colours, because it's plastic, we'll be able to, within reason, have a selection of colours, which we can work with. Standard colours, or if this is very special, obviously the customer has to pay for it, but we could in theory, and I think in practice, provide some special colours as well, should somebody have a specific need.
Got it. Okay, so at the end of the day, it's really going to be your typical dark bronze type color, or the clear
or black,
anodized.
or white, or silver. The anodized, same color. It can be the same color as, within reason, the same color as the seal if people are used to that kind of color. But what it does, it covers up it does two things really. It gives it a bit more impact resistance, but also it takes away the view of those ugly screw heads. That was my driver really, because I thought it didn't look very presentable. And no matter what you do, you can't hide them unless you cover them up, basically.
It's funny you say that, because I've seen lots of, as have you, surface-mounted automatic door bottoms in hotels, like the Hilton. Pardon me. Yeah, it's the Hilton at O'Hare Airport in Chicago, where I'll stay there if I'm just, it needs to be convenient. That hotel has got to be 35 years old, and those things are beat up on those doors. And having a plastic cover that you could peel off and snap a new one on, that's an interesting idea.
Because all you literally do is open the door. What we're going to do is put a little screw at the end. So basically, if you can imagine, there's a spider-shaped slider. So when you just screw it, just holds it in place. But yes, you can literally slide it off and replace it. It takes 5 minutes, if that. It's as quick as. You don't have to take the seal off. Open the door, slide the old one off, slide the new one on. Job done.
Yeah, I'm going through. I've checked my notes, and the slide cover, is that something that you're still anticipating being able to send at some point in the first half of December?
Yes. No.
Okay.
No, we won't, because the reason is we're just wrestling with our. It's an interesting point, actually. We're wrestling with our casing supplier at the moment, because I'm trying to get them to tighten up the tolerance on the casing itself. And so the new casing will be ready probably the first or second week in January. I'll be actually placing an order hopefully this week, and we'll get it done as soon as we can for both the plastic cover and the aluminium casing, which I'll get a sample as soon as it's available. I'll send a sample over to you immediately for your use.
Yeah. That sounds like it'll really be a version 2 situation. So regarding the DWGs, I had no need for them myself, and realizing the nature of what those files are. What would be nice would be to, if whatever you have, print it as a PDF. Because
I can do everything for you. Yeah, all the PDFs are fine. No problem.
Because there are people who, they want to see that, because we did a job for the Museum of Fine Art in Houston about 3 years ago, and all the hardware shipped to us. We sent it all to Germany, where the doors were built, and it all got shipped to Houston. And those guys over in Germany, I mean, they obviously, these doors were utterly, built. Every square millimeter was customized. So guys like that want those files, because, we're using that product, and we just want to build around it. So in those instances, I'll reach out to you and say, hey, let's talk about it. But until then, PDFs are great.
Okay, I'll make sure you get a full range of the PDFs, and there's a couple of blow up ones as well, and I say we'll be doing a proper PDF of this new casing setup as well. So we'll get all of those things done and make sure you get a copy of those within the next week or so.
Yeah, that's awesome. Okay, so basically all the PDFs I have are all the supporting documentation that are important for me to have, cut sheets and whatnot. So to get what the remaining PDFs from you sent over, and in particular, any document that would act as, unless I've got it and I'm not seeing it as I'm looking in my emails, would be just a document that we would call just installation instructions, step 1.
Okay.
Now I know that there were, they're at my desk. I got them. Okay, that is the cut sheet, and these are the quick guides. Okay, so anything that would act as installation instructions would be really handy, because what I'll end up doing is when I make the video, I end up digesting the entire product line and then sending it off to my gal in Switzerland or wherever, Austria, I'm not sure what country she's in right now, and she just adds the product to the website. But I want to batch all that to her at once.
Okay, that's fine. I'll go through the list of what we've sent you, and then make sure that you've got it. I'll supplement it to make sure what is missing you got as well.
Yeah, okay. And then what I'm going to want to do if it happens this week, great. Good. Luckily for me, I don't travel again for another 5 weeks. So, I'm here. I'm, healthy. Christmas falls on a weekend this year, so it won't be a substantial interruption to work. So if it's this week, great. But the amount of time it will take for me to be dedicated, this will be 2 hours for me to look at everything and to be focused exclusively on it. And Saturdays are my days to really be able to focus. I don't have that much time Monday through Friday to be able to not be interrupted. And then at that point, would you please email me what would be your information in terms of me creating a purchase order, so that I can, once the products are in the site, I can then create a purchase order and send you an order, at which point I'll ask you for probably wire transfer information if that's typical for you folks, for payment.
Yeah, fine.
We're going to put some of that stuff on the shelf, and we're going to start to immediately promote it. I kind of can't keep my hands off what are likely 18-inch samples that you sent, the cutaways. I'm glad that I have more than one, because I want one at my desk, and I want one up front as well, because here in Florida, people walk in, they're just looking to seal their doors, man.
Wow. It's interesting. We've just done two 1750 millimeter long seals for a customer in the north of England, and it works perfectly well. So it's just under 6 foot. So it just shows you and it has, you and I have talked about it before, but actually it has a great opportunity. Almost, you can almost take standard sizes and cut them down if you wish to, as time goes on, if they work out for you. And it's very, very easy, provided we could supply you with a variety of rod lengths. So you can actually, if you have some strange sizes coming in and you have an immediate need, you can cut seals down and adjust them, and it's ever so easy to do. You can do that on site without sort of waiting for me to ship things over to you.
Yeah, my approach to that initially was to not just put 36-inch lengths on the shelf. I know that we've got 4-inch that can be trimmed on all sizes above 24-inch. So it's definitely going to see us doing some, probably 3 different sizes. Actually, no, that's not true. It'll be more than that, because I'm going to want to be able to get out to 4 foot. So it's probably going to be a 48. It's going to be I'm sorry for speaking in imperial. It's just
4. That's okay.
48.
No, I'm used to. No worries.
Yeah. 48, 42s, and then probably 36, 32, and that might be just it, because our need for really narrow ones is very few and far between.
Yeah. It's interesting. I'm looking at an opportunity at the moment, possibly to have the casings extruded in the US. I'm talking to somebody at the moment, because I know you did mention there may be an opportunity, not maybe now, maybe somewhere down the road, maybe next year, you might look at potential assembly or acting as a bit of a hub. But that's obviously an opportunity you need to consider, and see how things work out with the seal generally.
Yeah, what I generally find is if we leave the barn door open, the horse is going to get out. And being able to, if the demand organically grows to the point where that makes sense, then if it's a matter of getting the order or not, that's kind of what we've always done, just adapt to meet the market demand, and that's what would drive that. Yeah.
Well, I say, slowly catching monkey, as they say, and let's just see first steps, and it'll be thank you very much for your support anyway, and I'm sure it'll work out for us both, hopefully.
Absolutely. I'm very grateful to have received the parts. It is extremely, it sells itself is what I'm trying to say. It's just those cutaways sell themselves. So send me your supporting documentation and the other stuff that I've requested, and we're going to stay on target, notwithstanding me being impossible to get a hold of for 3 weeks. Get stuff on order by the end of the year.
Okay, wonderful. Okay, that's super. Okay, well, I'll go through the documentation, get it over to you in the next day or so. And I told you just dropped something in the kitchen. That was a noise. And I look forward to speaking again. Well,
Thank you very much, Ryan.
Looking forward to seeing this video. I'm sure it'll be fantastic. Thank you so much. Thank you,
you,
Richard, anyway.
You Bye-bye.
Take care. Bye.
Architectural Builders Supply hopes you have enjoyed this program. Now, in conclusion, why should you consider the PDB or the Parker door bottom over many, many other manufacturers? Well, as I had said initially, it's a confluence of all of the advantages you didn't realize that were important. And it's reasonably priced. It's extreme high performance without the extreme high performance price tag, and without the disadvantages that those much more expensive units have. And that's, for me personally, the lack of elegant uniform dropping and the lack of elegance in terms of the physical overall size of those larger units. Oh, and I forgot to mention, in my 32 years, can you hear that clicking? Sure you can. My microphone is pretty good. You'll hear it. In my 32 years, 29 years ago, I had a client call. Yeah, remember that automatic door bottom you sold me? Sure, that was a good one. It's awful. And I said, what? Why? I'm sorry, explain. It wasn't that it didn't seal. It wasn't that it didn't work the way it was engineered. The client's complaint was how much noise it made when the doors opened. The clanking. And I thought, you may know what was first that I thought, but after I realized that's a legitimate statement, I thought to myself, I never thought about how much noise it opens when the doors opened. I only ever thought its effectiveness at sealing. And I realized, well, it wouldn't bother me, but who am I? And that client had every right to be bothered by that sound. In fact, she yanked it off the door, and that was the end of it. This, I can tell you, is I'm not going to get a measuring tool for acoustical energy, but I can tell you that minor clicking is probably less than what you would hear from the hydraulic fluid flowing in the door closer. Very, very quiet. Very quiet. And then, in fact, it happened to me maybe 20 years later. Client said, wow, those are really loud. Really loud. And I said, yeah, you're right. I've sold thousands of these, and there are 2 people that brought this to my attention. Now, statistically tiny, but nonetheless, equal in magnitude in terms of it being a product review. The amount of energy, the amount of sound or acoustical energy that a typical automatic door bottom gives off is not discussed. Earlier this year, a client with a severe sleep disorder, and all of us can understand, hey, I just want a good night's sleep. This client sleeps in such a shallow state that apparently, like medically verified, that even the sound of the latch bolt hitting the strike plate will disturb this gentleman from sleep. So that gentleman was looking for all possible means to deaden the sound of the operating hardware. And he was looking for a latch, but we were able to navigate automatic door bottoms for the quietest operation possible. Sargent many years ago made a latch bolt with an inserted nylon face to it, nylon leading edge in the latch itself. So it was intended, its purpose was, it was quieter. It did not make as much sound, and this client was not aware of that. And that conversation we had, which in that conversation I told him everything I knew about that discontinued Sargent 8 line. He then took that information and found a manufacturer, Accurate in Connecticut, who would not only give them that sort of feature on the latch, but the entirety of the lock itself, all of the internal components, were plastic in nature. Okay? And it turned out that that lock was extremely expensive, but it was exactly what he wanted. And I don't know if he ordered it, but he was looking for answers, because we can all relate to, I just want a good night's sleep. So acoustically, it's really, 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 comparatively, it's quiet compared to all the competition. It's not silent, but it is just a clicking sound. The larger the automatic door bottom you get, the more the clank that you hear, because it takes more force to drop that and more force to pop it back up, so you really hear a clank. It's a clank. It's not a click. As I said earlier, I've been to England. I've met Brian Parker and the team, and they're extremely knowledgeable about their product. They're extremely proud of their product. They're extremely gracious and attentive when it comes to their product line. And they're looking to bring back the sort of sales numbers that they once had when it was licensed under PEMCO. So don't underestimate the value of it being silent or closer to quiet than other models. A lot of the reason automatic door bottoms again today are being installed because they want to stop the transmission of sound. Ain't no good when the door clanks every time you open it, because for the obvious reason. But the gentleman I just referred to with the sleep disorder, I have sold automatic door bottoms to customers for bedroom applications. And you can be sure that the conversation I have with them immediately is, we need to select one as quiet as possible, because you're putting it on there. Why? Someone's in the room sleeping. That's why. And when you open the door to enter the bedroom, you don't want to disturb them with sound that you can't mute. There's no way to mute the sound. You can be quiet, and you can tiptoe, but you can't prevent clanking. This clicking is probably not going to get most people's attention ever at all. So that's really one heck of an advantage. So we talked about, the overview of why you consider Parker automatic door bottoms, the team themselves, all of the key benefits that we went through earlier. And with the exception at this time of needing to install this onto a 3-hour UL listed fire door, I can't think of a reason that this will not work for you. Well, if you've got a 1-inch drop and you have to have something that will drop 1 inch, this will never work. A 3-hour rating, there's no way to give that to you. But off the top of my head, looking at all of my key benefits and features, I can't think of a reason why it will not work for you. Dollar for dollar, I think it's the model to go with. We endeavor to keep the material in stock. It's relatively easy to thoroughly resize should you need to go in and do surgery on the unit. But if you're just trimming it 4 inch or less, just cut. I'll cut, as you saw earlier if you watched all of this, I cut it by hand. I wanted the experience of cutting it with a hacksaw to really get to know the product. In the future, that's going to be a 7¼ inch chop saw with a 60 tooth carbide blade in it. Done. I'd pull the EPDM back, I'd cut it, I'd drag it back. I'd clean the end of it with a file, I would drag the EPDM back, and then I would trim that, leave it long, and then do final trimming once it was installed. If you have any questions on any of the Parker door bottom units, or any sort of aspect of what Brian Parker and his team are getting up to, they are working on the rest of the perimeter gasketing as a solution. They are going to provide in 2023 all of the components to hit that STC rating without having to rely on another manufacturer's product line, so that there will be a single source for bringing STC ratings to openings, along with the other benefits that we've mentioned. Any questions on anything Brian Parker door bottom related, please feel free to reach out to us. Thank you. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.